Good evening, sir.
Good evening. Good evening.
Good evening, sir.
Am I audible now?
Yes, sir.
Yes, sir.
Is the
Yes,
screen
sir.
is visible to all?
Yes, sir.
Yes, sir.
We will start the session in 5 minutes. Okay.
Okay, sir.
Sir, in today's session, could we proceed like could we do week 7 to 9 first and then week 5 to 7?
It will be today's session for 5 to 7. Then after that, actually, this session was 5 to 9. So I just talked to them and then asked for split this session into two parts. So today's it will be cover of 5 to 7, and then for tomorrow's session I will cover 7 to 9. Okay. So this whole thing will cover in this revision session for 5 to 9, week 5 to 9.
Okay, sir.
Okay. So
Sir,
this
in
session
calendar
will be
there is
similar
no
as yesterday's session.
next
Yes.
session tomorrow.
Yes.
Sir, in calendar there is no next session tomorrow.
Yeah, that will be updated. That will be updated. No, don't worry about it. That will
Sir,
be
we
updated.
have a session
I
tomorrow from 6 for solving the PYQs.
This session will be on same time, like 8 to 10.
No, sir, that is from 6 to 8.
No, no, no. This session will be updated on your calendar. Don't worry.
Okay, sir. Okay.
Because this is the extra session that I have
At the
mentioned.
same time.
Sorry. Sorry. Actually, this session for tomorrow's session that was not planned. I request them for tomorrow's session because it's very difficult to cover week 5 to 9 in one session. Like just same as yesterday's session, the duration of the session was 3 hours 30 minutes, I guess. So it will be very difficult for you as for you guys to like sit in for three and a half hour and listen properly. That is why I split this session into two parts. Okay, so that I will get some more time to explain the topics. Okay, so is it fine for you?
Yes, sir.
So tomorrow's session will be on 8 to 10 only. Okay.
Okay, sir.
Is there any session running now?
No, sir.
No, sir.
No. Yeah, right.
Excuse me, sir.
Yes.
Sir, is there any session for revision of statistics weeks?
PYQs, statics. You just check on your calendar. Yeah, that will be, I guess, since I am not a course instructor of that stats part, that so I don't have any information regarding that.
Sir, can we please have a revision session for like the trigonometric basics, which would be evaluated in the end? Because it's quite confusing. Like earlier, we were informed that we just don't need those advanced identities and all that. But while going through the PYQs, I realized that there are some questions which utilize those concepts.
Okay, so what I will do, I will just recall that thing. And there are some basic formulas for trigonometry. So someone please message me on my Gmail. I will share with you for especially for trigonometric formulas. So that will be helpful for you to solve that kind of question. Okay.
Okay, sir. And sir, can you please post that document on Discourse if possible?
It's very difficult because I don't have any access for discourse
Oh, okay, sir. Okay.
because I am just a new instructor. So I don't know how this thing will work. So if you want, you can just contact me on my email. Okay, I will write my email.
Okay, sir. Thank you, sir.
Today's session will be week 5 to 7. Okay, so here is my email. You can contact with by this email.
Okay, sir. Thank you.
Okay, so let's start the session. Okay, so basically what we will discuss in today's session, what is the today's agenda is, we will discuss for week 5, 6, and 7. Okay, not the whole thing for 7. We will take some sequential part from week 7 and then we will stop this session. So basically in week 5, we will start from one function that I have already covered in yesterday's session, one-to-one function. Then compositions are there, composition of or composite function. Okay, then exponential, then logarithmic, and some arithmetic, some transcendental function. Transcendental function, it means that these are also count as transcendental function. Or you can say some trigonometric. Sir, the parts which are important for exam, will you cover that only? No. This is kind of revision session. I was thinking like that I will cover only that particular thing. But in yesterday's session, I realized that if I will cover whole thing, that will be very useful for you. So you don't need to expend much time on the revision part. You can, after this session, you can easily go through the questions as well. So you don't need to worry about it. I will cover a whole thing, whatever thing is discussed in your class. Okay.
Okay, sir.
Okay. So in this transcendental part, see this in the transcendental part, these functions are also transcendental function. But basically, I will go through trigonometric function and what else? Trigonometric functions. Yes, that's only trigonometric functions are there in your course. Okay. Then I will cover what is tangent, then graph, and then some sequence, what is sequence, and then convergence of a sequence. That kind of thing I will cover in a detailed way. Okay. After that, I will stop this session. Maybe this session will live a bit long, just like yesterday's session, because these topics are a bit tougher than yesterday's, because there was some easier topic. So maybe this session a bit long. So if you need a break for 2 to 5 minutes, you just comment on chat box. I will give you some break in between the class. Okay. So be patient for this class. Okay. And also one more thing that I want to conclude. If you have some doubt, okay. So if you have some doubt on any specific topic, just stop me on that particular topic. I will take your doubts and I will try to explain your, I will try to explain those things. Okay. Okay. Please answer.
Yes, sir.
So this is basically, just a minute. Okay. So this is basically one-to-one interaction kind of thing. I will ask some questions just like yesterday. I hope you guys have already watched that yesterday's video. Okay. Okay, so let's start the session. So yesterday what we have covered? We have covered the definition of function. So what is the definition of function basically? Function is nothing but it's a rule, right?
Yes.
Oh, thank you so much, Vishnu. So what is function? Function is a rule. It's a, just a minute, okay. Okay, so what is function? Is basically function. It's a rule. What kind of rule it is? It's a rule from a set A to B. Okay, these two sets are non-empty. That I have already explained why it is non-empty, because whenever we want to make some relation or we want to make some function from a set to a different set, so we need some element. If the elements are if the sets are empty, so we cannot make any kind of relation or any kind of function on those particular sets, right? So it's a rule from set, it's a rule from a set A to B. Okay, so what kind of rule it is? I explain those two particular things. The first thing is each element
Of A has an image in B.
exactly each element of A has an
In B.
image
in set
B.
B.
And what is the second?
Sir, each element should have only one image.
Yes, exactly. Each element.
There is just a definition of one-to-one function or a function.
No, it's a definition of function. I will explain what is one-one function. What is the basic difference between one-one function and then this function? Okay. So each element should have each element of A. Okay, this thing is important. Each element of A should have
Only one.
One image.
unique image. Okay.
Okay.
So what is it is? What is that? Suppose this is your set A, this is your set B. So if this set has suppose x1, x2, some xn elements, and here suppose y1 up to some ym element. So what is that? This is saying each element of A has an image in B. But here this is not specifying that how many image a element of A can take. Okay. So for that I include one more statement that if that all the elements, what are the image this element is taking, that image should be unique. It means that this x1 cannot meet any other element of this B. Understood? That was the definition of function. Then after that we have learned about one-to-one function. What is one-to-one function? What is one-to-one function? Can someone quickly tell me?
Equal to x2.
So what is one-to-one function? A function.
F of x1 is not equal to f of x2.
Yeah, exactly. A function f from a to b is said to be one-to-one when if for any x1 not equal to x2 belongs and x1 x2 coming from a, your fx1 will not equal to be fx2. That was the definition. So what is exactly it means? It means that suppose your function is defined. Okay, your function is defined from a to b. And this is
Yes,
your
sir.
1, 2, 3. Suppose 3 elements are there, and here suppose 4 elements are there, A, B, C, D. Okay. So
Okay.
it is saying if the set B, the element of set B, suppose A is taking A has some pre-image. It means that suppose this one maps to A, then the number of pre-image of element in B is at most 1. Has at most 1. What does it mean? It means that if A belongs to, suppose if X belongs to B, this is B is your codomain set. Okay, this is your codomain of F. So if X belongs to B, then there exists at most one element in A, say Y, such that, or suppose here this is Y. Okay, so it will be more, say X, such that fx is equals to Y. So what is it means actually? Means that if a element of B is having some pre-image, then that pre-image should be unique. You are getting my point? It does not mean that 1 is mapping to A and 2 is also mapping to A. That
No,
kind
sir,
of thing
this
will
one
not
is
happen
wrong.
in the 1-1 case. Yes?
Yes, sir. Yes, sir.
Understood? That thing will
Understood.
not happen in the 1-1 case. Okay. So that was up to this.
Sir.
I have covered.
Sir,
Yes.
one doubt, sir.
Yes.
So, yeah, it should not, I mean, two elements should not be mapped to only one element in case of 1-to-1. Let's say if 1 is mapped to A, 2 is mapped to B, 3 is mapped to C, can we have an element D in B that is not mapped to A at all?
Yeah, that can happen. That can be possibility. See, in the definition of function, I have mentioned only about A. Okay, I did not mention anything about B. There may be possibility that all the elements of A are mapping to Y1 only. Okay, there may be possibility, but there is only one condition. That condition is saying that the element of A can have only on one image. Okay.
Right.
Firstly, every element of A has image, and that image should be unique for each element. It does not mean that x1 is mapping to y1 and x1 is also mapping to y2 at the same time. That should not happen. Just like you can think about an, just a minute. Okay. So for example, you can think like that. Suppose you have a class. Suppose this is a class of foundation batch of IIT Madras. Foundation batch. Okay. And it has five students, A1, A2, A3, A4, A5. Okay. And another thing here is you have marking scheme from 1 to 10. 1, 2, 3, up to 10. Okay. This I hope this example will work for you. So this is your foundation batch class and this is your marks. Okay, marks in terms of 10 credit. In terms of 10 credit. So just tell me about it. If this person will get marks, then that mark, see, if these guys are appearing in the exam, so every person will have will get some marks, right?
Right, sir.
Every person of
Yes,
foundation
sir.
batch will get some marks. But if A1 is getting, suppose A1 is getting 3. So is there any possibility that A1 will get 4, 10, that kind of thing? No, right?
No.
No. So that kind of thing is known as function. You are getting my point?
Yes, sir.
Yes, sir.
Okay. So each element of the domain set will have image, and that image should be unique. Okay. One element of A cannot map to the two elements of A or more than two elements of A. That is the definition of function. Okay. So what is the difference between one-to-one function and definition of function? Here in the definition of one-to-one function, we are talking about B. Set B, your codomain set. In this case, we will say if suppose element of B either an element of B either has 0 image or it has 1 image only. There is only two possibility for elements of B. Two possibilities only. In the case of one-to-one function, either this A has 1 image or it does not have any pre-image. Sorry, not image, pre-image. You're getting my point? So for that, I explain this condition. This is saying if x1 is not equal to x2, it means that if you are taking two distinct elements, then the two distinct elements of what? Two distinct element of A, then the image of this two distinct element will be distinct. You got my point?
Sir, one small doubt, sir. What is pre-image, sir?
Pre-image, it means, okay, that I forgot to conclude you. Pre-image means it's obvious by its name. If your F1 is mapping to suppose, okay, in this example, if FA1 is equal to 2, then what we will say? We will say 2 is an image of A1, right?
Okay.
Okay, that thing you know. That in the same time, at the same time, we will say A1 is a pre-image of 2.
Oh, okay, sir.
Okay, but the condition is A1 has exactly one image, but this 2 can have more than one pre-image. Okay. In the case of fx is equals to x square. This is your function. Okay. So f1 is 1. F minus 1 is also 1. So for 1, what is the image of 1? It is 1. What is the image of minus 1? It is 1 only. But what is the pre-images of 1? It will be 1 and minus 1. You got my point? Got my point?
Yes. Yes,
Yes,
sir.
sir.
Okay.
Yes,
Okay.
sir.
So, yes. Okay. So, see, one function is clear. So, what is the basic difference between definition of function and one function? The basic difference between one function and definition of function is, in the definition of function, we will talk about domain. Okay. In the definition of one-to-one function, we will talk about codomain. Okay. So, one basic doubt that occurs in general, that, sir, you are saying if x1 is not equal to x2, then fx1 will not equal to x2, fx2. But sir, somewhere I am thinking that does this definition is true? If fx1 not equal to fx2, this implies that x1 not equal to x2. Does this is also implies the definition of this implies the definition of one-to-one function?
No,
This is
sir,
the
this
basic.
is not true.
This is not true, but this is the basic doubt that can be occur from in general. Like when I was in your stage, I was also thinking, does this implies one-to-one function or not? So why so? Because here it is saying if fx1 not equal to fx2, then this happen. But what about when fx1 equal to fx2? Just
X1
example,
is
if
equal
you
to x2.
yeah, if you have this graph and I will take this line, suppose this is your graph fx is equals to x square. Okay, so if I will take x is equals to 1, so fx sorry, fx is equals to 1. So in this case, you will get x square is equal to 1 and you have two images, x is equals to plus minus 1. Okay, here I am taking fx1 equal to fx2. Okay, it means then if you will take fx1 equal to 1 in this example and fx2 is also equal to 1. Does this implies x1 not equal to x2?
No, sir.
Not always, right? Sorry,
Yes.
x1, yeah, not always, right?
Yes, sir.
Okay, what I am basically trying to convey you, I am trying to convey you, this is not true in general, because not true in general. Why? Because here this person is talking on about only when fx1 not equal to fx2. What happened will fx1 equal to fx2? Then we cannot say anything about x1 is equal to x2 or not, or x1 is not equal to x2 or not.
Yes,
Got
sir.
my point?
Yes,
In
sir.
this case, if x1 is not equal to x2, then in that case, your function will not become 1 function, because your x1 is not equal to x2, but fx1 equal to fx2 by according to this example. You got my point? Because if you will take fx1 in this example, especially fx is equals to x square. Okay, just listen to me carefully. In this example, if you will take fx1 not equal to fx2, it means that what you are taking, this is your graph. This is your graph. Okay. So you are taking, suppose your x1 is here, your x2 is here. Okay. So, you know, in this case, x1 and x2 will be different. If this is your x1, this is your x2. So this will be different, right?
Yes, sir.
Right.
For example, you will take 4 and just take what? 9. Okay. This is your fx1 and this is your fx2. So in this case, x1 and x2 will be different, right?
Yes, sir.
But
Yes.
this is not a 1 function. You can see this
Yes, sir.
function is satisfying this definition, but this is not a 1 function, right?
Right.
Right. So that is why we will not go through this definition. This is totally wrong for the 1 function. Okay. Yeah. One more definition is coming from for 1 function. It is just the negation of this statement. That is saying a function f is said to be 1 if fx1 equal to fx2. This implies x1 equal to x2. Okay. This is also a definition. So whenever they will give me a function, suppose you have fx equal to x cube, and they will say just prove that this function is 1 algebraically. Not you are not going to use that vertical line test, that horizontal line test. He is just saying please mute yourself. He will just ask to me, just please mute yourself. Okay. Then he is just asking to me just to prove that this function is 1 algebraically. So how will I prove? I will assume, if possible, fx1 equal to fx2. Okay. Now I am assuming this. Okay. Then if I am able to prove that x1 equal to x2, then I am done. Right? So
Right.
in this case, what I will get? I will get x1 cube equal to x2 cube. Then we will get x1 cube minus x2 cube equal to 0. Then from here, what you will get? X1 minus x2. Then x1 square plus x1 x2 plus x2 square equal to 0. This thing always be positive. This thing cannot be 0. Okay. So what you will get? X1 minus x2 equal to 0. This implies x1 is equal to x2. I get what my point?
Sir,
Okay.
how can that be always be positive, sir? X1 and X2.
Okay. Okay. This is positive because if this is not positive,
Mhm.
sorry, not positive. This will not equal to be 0. Okay. Sorry. Not positive exactly. This will not equal to be 0. Why? Because see, if you have x cube is equals to a cube kind of thing, that you know, in this equation, this function have only one real root.
Okay, sir.
Right? Only one real root. In this case, other two roots will be imaginary.
Okay.
Right? Imaginary. It means that if this thing will not have any roots, it means that this thing will not equal to be 0 for any for any value of x1 and x2. You are getting my point?
Yes, sir.
If this equation does not have any roots, it means that this equation will not have any roots. There does not exist any point where this equation will go to 0. Right?
Right, sir.
Right? It means that if this is not equal to 0, I can directly suppose this is not equal to 0, this is equal to some k. So this is constant. I can directly apply that cross multiplication and I will get this. Because one of the members should be 0. If if multiplication of two real numbers is going to be 0, it means that one of the real numbers should be 0, either this 0 or this 0. But we know that this is not equal to 0, so it has to be 0. You got my point?
Yes, sir.
Okay, so from here you got this x1 equal to x2. Okay, so it means that this function is 1. Understood the concept, how you will go through that particular thing, this function is 1 or not. Okay, so this is an algebraically way where you can show a function is 1 or not, but this is slightly difficult. So apart from that, if you have to solve that kind of question, like if you have some objective kind of thing and you need to solve that kind of question, so for that there are some basic tools that you can use, just like increasing, decreasing order, or you can say that horizontal line test, that vertical line test, that kind of thing is happen. Okay, so after that there is two things which is known as vertical line test. First is vertical line test. Okay, so what is it? And the other thing is horizontal line test. Okay, so what is vertical line test basically? So this is saying, this is nothing but this test we will use when we have to prove that this is function or not. Okay, this is not for 1 or not. This is only for if you have some curve like this. Suppose if you have some curve like this, and he is asking to me, just so does this curve is function or not? So for that I will apply vertical line test. So what is vertical line test is saying? Say he's saying, according to this test, they will say just draw a vertical line in the domain. Draw a vertical line. Okay, like this. So if this line cuts your curve into more than one part, then if this vertical lines cuts my curve into more than one part, then that curve will not become, then the curve is not a function. Got it? Okay. Why it is not a function? Just take an example. Suppose you have this graph. You know, this is the equation of circle, right? But this is not a function. Why? Because it fails the vertical line test. So why so it is not a function? See, actually what this cross is showing, suppose here you have x1. Okay, and this is some curve, suppose gx is your x1 x square plus y square minus a square. Okay, this is your curve. This is your definition. This is your equation of circle, right? Everyone aware of it?
Yes, sir.
Okay, this is the definition. This is the equation of circle centered at origin whose radius is r. Okay, so
Yes,
in
sir.
this case, what you are seeing, if here see, what is the value of x1? Here x1, if you are taking x1 as input, you are getting two outputs, right? Here and here, right?
Yes, sir.
So this is failing our definition of function,
Yes,
right?
sir. Right, sir.
Because here fx1 is getting y1. Suppose this is your y1 and this is your y2, and fx1 is also getting y2 as well in the same time, and y1 and y2 both are different, not equal, right? Sorry, fx1, right? So it is not a function. Why so? Because here x1 is there and here y1 and y2 is there. Here x1 is meeting to y1 and y2 at the same time. So that is why this is not a function, right? So vertical,
Yes.
whenever you will apply vertical line test, that test will be applied only for whenever you have to check whether this graph, whether this curve is a function or not. Okay. For example, if I will give you some example, okay. Okay, just tell me this is a function or not.
Not a function.
Why? Because if you will draw a vertical line, it fails a vertical
Fail
line test.
vertical line test. Yes, sir.
Okay. So this is not a function. So whenever you want to check whether this is a function or not, just make a graph and then see it
So
is
graph
satisfying
of
the vertical
x
line
cube.
test or sorry,
So graph of x cube.
graph of x cube. How it looks like? This is look like this, right? Okay, this is going towards 0. Okay, what is that problem here? Only cuts, only 1 points.
Yes, sir.
Okay, so this is a function.
Okay, sir.
Okay. Now after that, horizontal line test come into the picture. Horizontal line test. What is horizontal line test? Okay, so basically this horizontal line test is used for checking whether this function is 1, 1 or not. One more thing that you can see whether this function is onto or not. How? That I will show you. Okay.
Okay, sir.
Okay. So what is horizontal line test is showing? It is saying if so what is basically, and it is if suppose your graph, this is your graph. Okay. This is your graph of a function. So just draw a horizontal line like this. So if your horizontal line cuts your graph more than 2 points. What I am saying, if your horizontal line cuts the graph more than 2 points, if the horizontal line cuts the graph, or you can say cuts the curve in more than 1 point, more than 1 point, then your graph will not be a one-to-one function. Okay. See, when I will apply this horizontal line test, only when that particular graph will become a function. Okay. You're getting my point. This test is only for functions, because here I am applying this horizontal line test only why? Because I need to check whether this function is 1-to-1 or not. There is no such use of horizontal line test except this to 1-to-1 and onto property. So if the given curve is not a function, then there is no point to test this horizontal line test, right?
Right, sir.
Right? There is no such point to test this horizontal line test. So firstly check the given curve is a function or not. If it is a function, then go through the horizontal line test for checking it is 1-1 or not. Okay.
Okay.
Yes, sir.
Okay. So if this horizontal line test, if any horizontal line test, okay, I'm not saying there are infinitely many. I am saying if any horizontal line test cuts your curve, if any horizontal line cuts your curve into more than one parts, then we will say the given function will not a one function. You got my fine? Okay.
Yes, sir.
Now,
Yes, sir.
how will you check it is a onto or not? See, if your function is defined, if your function is defined, it means that they have given your domain, codomain, that thing you have, right? That thing you have in your hand. Codomain was there and domain was there. Or you can find the domain as well, right? But we will not talk about domain here. We will talk about codomain here. So they will give you codomain for sure. Okay. Now,
Yes.
there is two ways to find this is a onto or not. First thing, if codomain is equal to range, then it is done. Okay. The other way is if you are able to make a graph, then you can easily see whether by horizontal line test whether it is a 1 1 or not. How you will see? See, suppose this is your example. Fx is equal to x square. Okay. Draw horizontal line. From here, you can easily say this is not a 1 1 function, but this is not a onto function. How will you say? Here, your f is defined from R to R. Okay. So just draw a line here. See, here, this line is not cutting any part of this graph, right? Not intersecting any part of this graph.
Yes.
Share question paper. For which question paper you are talking about, Yogeshwari? Okay. So these lines are not intersecting any point at any point of this particular graph. So what I am observing here, if
Excuse
the
me, sir.
horizon, yes.
Sir, what if that horizontal line passes at some point of graph and fails at some point of graph?
Sorry. Can you speak a bit more precisely? Can you speak louder?
So yes, sir. For instance, if there is a graph where horizontal line test pass from upper side and fails from downside, is it possible?
Just like this example, this example. Fails downside. Okay. So what you are saying, suppose this kind of thing happen. Downside, it means that downside in the in terms of x-axis, right?
Yes, sir.
Okay. So you are saying, suppose your graph is like that. Okay, like that. That kind of thing.
Yes, sir. Yes, sir.
Here it is past the horizontal line test, but here it is fails.
Yes, sir.
Yes. So in this case, your function will not 1 1. Because I am saying at least one that kind of thing happen. If at least one point this kind of thing happen, then that function will not be 1 1 on that defined domain.
Okay, sir. Thank you so much.
Okay. If there is a point where you are getting that kind of thing, okay, just draw a horizontal line. Okay. Okay. So
Okay,
Yogeshwari
sir.
is saying kindly share QP. I think there is some QP session, previous year question solving session. Okay. On SGRED IITM website, notes and previous year question papers are available. Okay, Preeti, can you please share that link to her? Okay, or just I think tomorrow you have a TA session for PYQs, solving PYQs. So you just join that question and ask for giving PYQs to them. They will give you. Okay.
Sir, today also we were having, sir, QP
Okay.
sessions.
Okay. You can ask.
This session?
Okay, you can discuss in your group. Let me explain what is this, how will you solve, okay? Okay, someone has shared that PDF. Okay, now, how will you check this is onto or not? What I am saying, just draw a horizontal line in the entire codomain and then see if the horizontal line did not cut at any point of your curve, any point of curve, then your curve will not be onto, or your then f will not be onto. Why it is so? Because you are getting some points. Suppose this is here, your function is not cutting here in this point, your horizontal line is not cutting to your graph. It means that you are getting a point y1 in your codomain for which this y1 is not getting any pre-image. You got my point?
Sir, so
Yes, sir.
basically that means all the horizontal lines should intersect the curve at some point or the other.
Exactly. If the function is onto, it means that all the horizontal line which is drawing in your codomain should cut at least once. Okay. Okay.
Okay, sir.
At least one point, the horizontal line will cut your graph. Just like this x cube example. Here codomain is R. So what are the line you will draw in entire codomain? You will always get a point where this line will cut. Like this, like this, like this. You're getting my point? There not be any point where this horizontal line test is failing. Yes?
Excuse me, sir.
Yes, yes.
Sir, according to horizontal line test, every odd degree function is a onto function.
Every odd degree function. What kind of odd degree function you are talking about? Every odd degree polynomial is an onto function,
Yeah,
you can
yes,
say.
yes, sir.
Yes,
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 sir,
that is true. That is true.
that's true. And it's a 1-1 always.
No.
Sir, in case of x cube.
No, x cube is 1, 1. That's true. But no, every odd function is not 1, 1.
Okay, sir. But okay. Every
Just see the
odd
example.
polynomial function.
This is
Okay.
also a odd degree function. It has 3 roots.
Yes, sir. Yes, sir. Yes, sir.
It has 3 roots. Okay. But is this function is 1, 1? 3 points are there.
No, sir. No, sir.
No, right?
Yes, sir.
Got my point?
Yes.
Okay. But it is onto. Okay. After that horizontal line test, you understood how you will use horizontal line test and vertical line test for proving this is a function or not, 1, 1 or not, or onto not. Okay. After
Sir,
that,
can you repeat vertical line test?
see, vertical line test is
Okay.
nothing but if you want to test this function, this is a function or not, just draw a vertical line in your domain. If your vertical line cuts more than 1 point, then it will not be a function. Okay.
Okay, sir.
Simple.
Sir, vertical line test for only for is the function is
Checking
a
it is a
function
function or not.
or not. Yes, sir. And a horizontal line is 1-1 or onto functions.
Exactly.
Okay, sir.
Okay. So here one term is coming, inversible or reversible. I have already explained this thing, right? Inversible or reversible.
Excuse me, sir.
Mm-hmm.
Sir, in this session, we are revise 5 to 12 weeks syllabus.
In this session, I will revise today. In today's session, I will revise 5 to 7, and tomorrow's session I will revise 7 to 9.
Okay, sir.
Okay. And
And
after
then
that,
10
some
to
other course instructor will come and then they will revise 10 to 12.
okay, sir. Okay, sir.
Okay. So what is reversible function? I already explain you what is reversible function. If a function can be made as invertible function, just like if a function is onto, sorry, 1 if a function is 1 then we say function f is reversible. Okay, why so? I already explained you yesterday what is the basic difference between inverse existence of invertible function or inversible function or reversible function. What is the basic difference? If this is your set A and B, suppose here A1, A2, A3 are there, here 1, 2, 3 are there, and this is mapping like this. So in this case, your f inverse exists or inverse of a function will exist, or we will say this function is invertible. Invertible. Okay. But if your function is onto, suppose here 4 is also there. Sorry, 1, 1. Here function is 1, 1. But this function is not invertible now. Why? Because 4 does not have any pre-made. What is the definition of inverse existent of inverse? If a function is 1, 1 and onto as well, then we will say this function has inverse, right? But in this case, this function is not onto. But if I will restrict your codomain, if I will restrict your codomain, if I will restrict your codomain, what is the means of restriction? I will exclude this 4. Then this function will become an invertible function, right? Then in this case, this function will known as reversible function or inversible function. You got my point? So if they will ask you, they will give you a function fx and they will say just find out whether this function is reversible or not. So what you have to do? You don't have to do anything. Just check whether this function is 1, 1 or not. If it is 1, 1, then this function is reversible. It means that if you will restrict its domain, then this function can be made as invertible function or this function have inverse. You got my point?
So for a reversible function, it should be 1, 1 and onto also.
Invertible function. For invertible function means it has inverse.
Yes.
Okay?
Sir. Yes, yes.
It means that that function will be 1, 1 and onto. And what
Okay,
is
sir.
reversible function? Reversible function means it is 1, 1. And why we are saying it is irreversible? Because if I am going to like strict my codomain, strict means if I will exclude those points where that point will not have any premise, then that particular function, after that particular function will become an invertible function. It means that that particular function will have image on that particular time when you are restricting your codomain. That is why we are saying this function is reversible. Got my point?
Okay, sir. Okay,
So
sir.
we can also say, like, if we put f of x to another function, then we will get a.
Sorry.
Suppose I put 1 to some other function, I will get a. So that function is inverse of this function.
Yeah.
Sir,
Yes.
sir, can you take the example as like fx is equal to 5 and gx is equal to also 5? Then these f and g are also inverse.
You are saying this is inverse of each other. Why?
Yes, sir. That's what I am asking you.
No, this is not. Now, this is totally different functions, right? You are saying, does this G is the inverse of F? That you are asking, right?
Yes, sir.
No, right? No, right? Because here your X is mapping to 5. Here also X is mapping to 5. If your G5 is X, this X is fixed value. So suppose X naught. Then you can say, yeah, at this point, this function is inversing that particular point, not the whole codomain. If this thing is happen for each point, then we will say, yeah, this function will become an inverse of this. This is, you are talking about only one point, but what else others?
Okay.
Okay. So got my point? Inversibility.
Yes,
So
I got it.
invertible and inversible both are same, right?
No, both are different. Both are different. See, just concentrate on the terminology. I am saying invertible function. It means that inverse is exist. Okay. Inversible function or reversible function means just, okay, forget about inversible function. Remember reversible function. Reversible function means that function can be reversed. It means that if I will do something in your codomain, then that for that function your inverse should exist. In this case, if I will exclude this 4, then this function have an inverse. Right?
Right.
So in this case, this function is known as reversible function, not invertible function. Invertible function, it means that that function, the inverse is exist. Here the inverse will exist. On that case, in that case, inverse is exist at that time.
When we remove
Got my
4 from codomain, right?
Exactly. Then inverse will exist. I'm not saying inverse is exist now, but if I will remove this 4, then inverse will exist.
Okay.
But in the case of invertible function, inverse exists at this point of moment as well.
Okay, 4
Got
will
my
not
point?
be there, right? 4 will not be there,
Yeah.
only A1, A2, A3, 1, 2, 3. Domain and codomain will be equal.
Yeah. In this case, we will say this function is bijective as well. Okay.
Okay.
Okay. After that, increasing and decreasing things will come into the picture. Just a minute.
Excuse me, is there anything called inversible function? No, right?
No, that is similar as reversible function and invertible function is there. Inversible function and reversible function, both are terminology and both are same.
Okay.
But they are not mentioning that particular thing in your syllabus. So I am just using that kind of terminology.
Okay, got it. Okay, thank you.
Okay, after that, just a minute. Okay. Okay, after that, increasing and decreasing. So, what is increasing function? Increasing function is saying, simply it is saying if x1 is greater than or equal to x2, then if for this thing, here x1 and x2 are coming from your domain D. See, I am not writing the formal definition. I am just explaining that thing. Okay. If I will write the formal definition, it will take too much of your time. So you have all the definition as I am thinking. Okay. So if x1 is less than or equal to x2, in this case, if this thing is
just to clarify, invertible function is both 1, 1 and on 2, and reversible function, we just need to check if it is 1, 1, right?
Yes, exactly.
Okay, so thank you.
So if this thing is happening for x1 is less than or equal to x2, and this thing is happening, then we will say this function is increasing. What does it means? Is exactly? It means that whenever you will take two distinct elements from your domain, and this what is the property of this element? This property of this element is like this: your x1 is less than or equal to x2. That kind of element whenever you will take, and for that always you are getting this thing. Okay, then you will say, yeah, this function is increasing. What kind of thing it is? Just like see this function. Whenever I will take two distinct x1 and x2 like this, here you can see x1 is less than or equal to x2. Their corresponding image is behaving the same manner. See, this is its corresponding image, fx1, or y1 you can say. This is its corresponding image, fx2. Here you can easily see your fx1 is less than or equal to fx2. Right? In this case, this function is known as increasing function. Okay? You are getting my point? What I am saying? I am saying whenever you will take, whenever, it means that for all the values of x1, x2, whenever you are taking this kind of element, where x1 is less than or equal to x2. You see what you will see. You have a jhola. Everyone knows what is jhola? Bag. Okay, bag. And here
Yes, sir.
this is your domain, and it's containing lots and lots of elements. Okay. Now you are arbitrarily choosing two elements, x1 and x2. And what you are saying, you are saying that x1 is less than or equal to x2. Now you are applying the function value. So in the functional value of x1 and x2, you are seeing that fx1 is less than or equal to fx2. And this thing is happening whenever this thing is happening. Then you will say, yeah, whenever I am taking this kind of element, this kind of property is satisfying, then you will say, yeah, this function is your increasing function.
But it can
As
be,
you can see here, yes,
it can be equal, right? Like the y values can still be equal, right?
yeah, that can be equal. That can be equal. Just like if you have this example here, I am using equal to sign, right? This is one of the example. I am not saying this is the only example. If you have this this function, suppose this is your function. Now this is like this. Okay, so this is also an increasing function. Why? You will say, no, sir, this is not a function. Why? Because if I am taking x1 here, x2 here, you are getting same y1. But here, see, x1 is less than or equal to x2, and fx1 is also less than or equal to fx2. No. Why? Because y1 is less than or equal to y1. Why? It means that either y1 is strictly less than or to y2, or y1 is equal to y2. If you are saying y1 is less than or equal to y2, this implies this, no? So this property is holding here. That is why I can say, yeah, y1 is less than or equal to y2. You are getting my point? So this kind of function is also an increasing function. Okay?
Sir?
That is why I am using here equal to sign. Yes?
So like in lecture, there was some notation, monotone increasing something.
That I will cover. That I will cover. Don't worry about it. Okay? That I will take. I know you have that particular doubt as well. What is the difference between monotonically increasing function and increasing function?
Yes, sir.
Okay. Now, that I will take. I will take. Don't worry. I will take.
In the given function that you have described now, is it a slant or is it a constant like function? The x1 and an x2.
Here it is constant. Here it is constant. Here this function is increasing. Here this function is increasing. But here it is constant. But still this whole function is an increasing function.
Okay.
At some part, this function is constant. Not entirely. Okay?
Yeah.
Okay, so this function is known as increasing function. Here, one
So for
terminology
any
I am using.
increasing, so for any increasing function, there is no such condition that the function should be 1, 1 or 1, 2, na?
Yeah, because this function is not 1, 1, na?
Yes, sir. Yes,
This
sir.
function is saying contradicting horizontal line test. Here, so many elements having same image. But here,
Yes, sir.
for that, I am using different terminology known as strictly increasing function.
Yes, sir. Yes. I have confused between them.
Increasing function.
Yes.
So in
Yeah.
strictly increasing function, there won't be a concept of equal to, right?
Yes. What I am saying, whenever you are taking this kind of element here, I'm not including equality sign. I am using strictness. Then you will get x1 is strictly less than fx2. Like this case. Okay. So in this case, whenever you have strictly increasing function, so one result is coming if f is strictly increasing. Okay. This implies f is 1 to 1. Why so? Because if your f is strictly increasing, it means that it is look like this. Okay. So whenever you will apply horizontal line test, it always pass that test. You got my point?
Yes, sir.
Understood? So if f is strictly increasing, then f will become 1 to 1 function. So this is the result. But in your lecture note, they are mentioning, they are mentioning increasing only. Okay, so just make sure that strictly increasing word, just remember what is it exactly. Okay, so every increasing function will not be on 2. Oh, sorry, 1 1. Why? Because you have this example here. This function is not 1 1, but it is increasing. Similarly,
Yes, sir.
decreasing function. Similarly, decreasing function. No need to explain that much, because similar as similar, increasing similar, this thing is happen. Okay, so in this case, if x1 is less than or equal to x2, this implies fx1 is greater than or equal to fx2. What is the example of this? This kind of thing. Suppose you have this. Okay, in this case, whenever you are taking this, suppose this is your x1, this is your x2. Here you are saying, see, x1 is less than or equal to x2, but in the case of functional value, here fx1, what is your fx1? This is your fx1. And what is your fx2? This is your fx2. See, you can easily see fx1 is greater than or equal to fx2. In this case, this function is known as decreasing function. Okay, after that, strictly decreasing function. Strictly decreasing function. So what is it? Similarly, if x1 is strictly less than x2, this implies fx1 is strictly greater than fx2. And in this case, also f is 1. Got my point?
Yes, sir.
Hello? Got my point? Easy, right?
Yes, sir.
Understood the definition of 1 function?
Yes, sir.
Yes.
And strictly increasing, strictly decreasing, decreasing, increasing. What is the difference between increasing and strictly increasing? Got my point?
Yes, sir.
Yes, sir.
Yeah.
Yes.
Okay. After that, I will explain you what is monotonicity. Okay. So what is monotone increasing function? Monotone increasing function. So what is this basically? Basically here, whenever you are talking about this increasingness, you are talking about only domain. Okay. So basically this increasing property is not for entire domain. This increasing property is for only a point. Okay, or a neighborhood of a point. This is not for entire domain. So basically, if a function f is f from a to b is increasing in entire a, then we will say f is monotonically increasing. Monotonically increasing in a. You got my point? If this function f is increasing in the entire a, you are getting my point? Getting my point? If f is
Sir, what
increasing
is the
entire a, what does this mean? Let me think. Let me show you. Suppose this is your function. Okay. So in this
yes,
case, you are you able to see or not? I am just saying, if you will take this portion, your function is increasing.
yes,
Okay, so this function is saying this function is increasing in this domain. Okay, similarly in this case your function is increasing, but in this case function is decreasing,
yes, sir. Yes,
right? So in this
yes,
case
sir.
this function is increasing in some portion. But if your function is like this, suppose like this function is entirely increasing in R.
Sir,
Okay,
then what is
entirely
the
increasing
difference
in.
between this and strictly increasing?
Yeah, sir.
See, strictly increasing and increasing, both are increasing. There is a slight difference between increasing and strictly, increasing and strictly increasing, that I have already covered. If you are using equality sign, then it is increasing. If you are using
No, sir, strictly
strictly,
increasing and monotone increasing. What is the
see,
difference between it?
monotone increase. This is also a monotonically increasing function, right? This is also a monotonically increasing because it is increasing in entire domain.
Yes, sir.
If it is increasing in entire domain, then we will say, yeah, this function is monotonically increasing in entire domain. Okay. Basically, this is just a terminology to show that particular, to represent that particular thing, whether this function is entirely increasing or not. In this case, this function is not entirely increasing.
Oh, okay, understood now. Means if the function is once decreasing and one increases, then it is not only monotonic, and if it is increasing in the whole domain, then it is monotonic.
Exactly. That's what I want to convey.
Yes.
Got my point?
Yes, sir. Understood. Now.
Now you are getting that point. What is monotone mean? It means that monotone means if it will start increasing, then it will increasing only. It will not going to be decreased at any point.
Yes, sir. Means it is going in same increasing pace.
Exactly.
Sir, in monotonically increasing,
What is strictly increasing?
Similar case
we
in
have
increasing.
like before where
One by one,
multiple
please.
x values
Can you
have
please-
the same y value. Is that allowed?
Sorry?
No, right? In monotonically increasing, we don't allow like a constant value to come for two x
What is
values, right?
strictly increasing, sir?
That is monotonically strictly increasing.
Oh, okay. So that is a
Here
separate.
I am using separate terminology because it is bit confusing.
Okay, so monotonically increasing is different from monotonically strictly increasing.
Exactly. For your case, they have mentioned both same things are equal, but I am explaining in this way because this is a bit confusing, because whenever you will use that one property, that theorem where you are saying every increasing function is a one function, but it is not true in general. That is why I am using that particular thing. Like if a function is strictly monotonically increasing, then your function is one in entire domain.
Okay, sir.
That is why this monotonicity is coming to the picture, because there may be possibility that that function is increasing in some portion of domain, like this. Okay, so basically this is just a terminology to represent that thing your function is entirely increasing or not. Means that if the function is started increasing, then it will increase in the entire domain. Sir, do we mark it as a false or true in exam? What? Okay. What is the question basically? An increasing function is one-to-one function. This statement is false, right?
Yeah.
This statement is false. I have given you the example. See, they have mentioned that thing, but whenever they will ask, they will definitely see that particular thing. Because
Sir,
this
can
is
you
also
please
an
repeat
example.
which statement is false?
This is also an increasing function, right? But this is not one, no? That was he is asking.
No, but sir,
Can you scroll the
a
screen?
monotonically increasing or decreasing function will always be one, right?
No. Monotonically strictly increasing function. Just use that strictly word here. Okay.
Yeah. Can you explain that monotonic part once again?
Monotonic part is nothing but it is just a terminology which is showing that if a function is start increasing, then it will increase in the entire domain. If this thing is happen, then we will say, yeah, this is monotonically increasing. Okay. If there is some that kind of thing happen where function is increasing, then decreasing, then increasing, that kind of thing happen, then we will say, no, this is not a monotonically increasing function.
From a certain point, it
with
keeps
respect
on
to
increasing.
then.
Exactly.
Like there is no difference, right? Monotone and
there is no difference. There is no difference. This is just a terminology for showing that thing. This function is increasing in entire domain.
Okay, sir.
There is no difference.
Yeah, so that is a difference between increasing function and monotonically increasing function. Increasing function can be for a particular portion of the graph, whereas for monotonically increasing function, it is for the whole graph.
Exactly.
Yeah.
Okay. Similar as a monotonically decreasing function. Okay. After that, exponential function is coming into the picture. Okay. Before starting this, I will give you 2 minutes back. Okay. This is necessary for me as well. Okay, just 2 minutes. Wait for 2 minutes. I just come. And then you can press off as well. Okay, so the thing is, this session will be a bit long. Please make some patience and be stay with me.
Sure.
Okay.
Yes, sir.
I'm coming. Hello. Hello.
Yes, sir.
Audible? Okay. Okay.
Yes, sir.
So difference between monotonic and strictly monotonic function. See, monotonic function, it means that either it is monotonically increasing or monotonically decreasing. Strictly monotonic function means either this function is strictly monotonically increasing. What is strictly means? I have already mentioned, right? If this strictly sign is coming into the picture, then we will say, yeah, it's strictly decreasing. And if it is monotonically strictly decreasing, what is it means? It means that this function is start decreasing and this is decreasing as well, like this. Like this function. This function is start decreasing from here, suppose here, and this is decreasing in the entire domain. Similarly, here either this way as well. Once this is start decreasing and it's decreasing like that. It means that this function is entirely decreasing in the entire domain. It means that this function is monotonically decreasing. And if it is strictly decreasing, it means that this function is monotonically strictly decreasing. Got it, Nivas? Basically, this is just a terminology, okay? Nothing else. Nothing is there.
Sir, in the exam point of view, like what kind of terminology will they be using? Will they be using monotonically strictly increasing function or strictly increasing function?
I think they will use strictly increasing function. Monotonicity is not so important. Basically, monotonicity is coming into the sequence part, not in general for function as well. So basically, this increasing property is not for entire domain. This is for a neighborhood of what is neighborhood. That's the big problem. This is the small portion of the domains. Is the small area, not for entire domain. That increasing property. Okay.
But I
And
feel
that
like in the exams they will only give, if they're asking a question, they will only suggest if it is strictly increasing. I don't think they will specify is it strictly monotonically increasing, right?
Exactly. They will not specify that kind of thing.
Okay, in which case, if when we are said like strictly, when we are asked if is strictly increasing function 1, we have to just say agree to it, right? We have to say
Yeah,
it is
exactly.
1.
In the exam point of view, their strictly monotonic, strictly increasing function means strictly monotonically increasing. Okay.
Okay.
Increasing function means monotonically increasing. They will not going to specify this thing
But
because
sir,
they did
if
not.
it's just given that like is an increasing or a decreasing function 1-to-1, what then?
Then you don't need to choose that option because you have seen this example, right? You have to be conceptually clear about that. This is increasing but not 1-1. This is also monotonic increasing.
Okay, sir.
Okay. So you have to be clear about your concept. I am saying now they have there is some mistake. Maybe in next term they will definitely recognize that thing. Okay.
Yes, sir.
Okay.
So increasing function we can say it is not 1 because increasing function can have like constant in between and still, because for instance x cube is like an increasing function but it has a saddle point in between. So it doesn't
but
make
x cube is also 1-1. X cube is also 1-1.
Okay.
X cube is also 1-1. Why? Because here only at 0, at x is equals to 0, you have only fx is equals to 0. You are saying here the function is constant. No, here function is not constant. But in this case, this is constant, right? You can see this
Excuse
graph.
me, sir. Sir, in the textbook for mathematics that's provided by IITM, sir, in that they've stated a theorem that if f is an increasing or decreasing function, then f is 1-1.
That's what I am trying to convey you, that is incorrect. That is incorrect. That is not true. Okay.
So, sir,
That is
in
what I
the
am
exam,
saying.
if we get such a question, then if we write false, that would be the correct answer, right?
Yeah.
Okay, sir.
Because exam paper, we are making that exam paper, right? And like our team members are making that exam paper. So they have that particular knowledge.
Okay, sir.
Maybe in the next term, they will correct that book. I will suggest that particular thing as well. Okay. Okay.
Okay, sir. Thank you.
Okay, let's start further discussion about exponential function. exponential function. Okay. So before starting exponential function, let me clear about some terminologies, which is like you have seen this kind of thing, right? Or this kind of thing, a raised to the power x kind of thing, right?
Yes, sir.
Here, this particular thing is known as base. This function is known as exponent. Okay, this is some terminology here. Now, here we have to see what value we can take for a, what are the value we can take for x. Okay, so for instance, if I will say, sir, a is equals to 0. Does this happen? No, right? Why? Because it will become 0 raised to the power x. Now, if you will take x is equals to 0, then you will get 0 raised to the power 0, which is not defined. Okay. Suppose someone will come to me and they will say, sir, please exclude that 0. Then what it is? It will become 0 only. Is there any sense to define that kind of function? This function will become constant function.
Yes, sir.
Right? So for that purpose, I am not taking a is equal to 0. Okay. Now, can a be negative?
No, sir.
No, right? Why? Because if you will take a is equals to -1, suppose, then -1 raised to the power x come to the picture. And if you will take x is equals to 1/2, it will become -1 raised to the power 1/2. In this case, this is also not defined. This will become iota, which is an imaginary number.
Yes, sir.
Right? So for this case, a is not a less than equal to 0. So a cannot be less than 0. So in this case, you have easily seen for this, a has to be equal greater than 0. What about this x? Is there any condition in this x? Okay. Suppose your x is coming from rational number. Okay, q. No issue, right? You can always define this kind of thing.
Yes, sir.
Okay, what about it is coming from irrational? Suppose your x is equals to 2 raised to the power what? Your x is equals to √2. What is the value of √2? 1.414 something like that. Okay, so in this case we can approximate. How we can approximate? So in this case I am saying what is a raised to the power x. So you see, we can write this, then we can write this, then we can write this, then we can write this. So eventually when I am seeing like this sequence, like this whole thing is, suppose a raised to the power, this whole thing is going towards a raised to the power √2, right?
Yes, sir.
Yes, sir.
Right? So in this case, we are able to define. So here, no such restriction for your x. So your x can be coming from R. Okay. Okay, got my point?
Yes, sir. Got it.
Okay.
Yes, sir.
Now, what is the definition? Now, after that, what is the definition of exponential function? So the definition of exponential function is saying, okay, definition. What is the definition? An exponential function is defined as fx is equals to a raised to the power x, where a is greater than 0 and a is not equal to 1. Why so? Suppose in this case, if a is equal to 1, then you will define 1 raised to the power x. So whatever value you can take x, you will get 1 only. Then in this case, your function will become constant function.
Yes, sir.
Right? So in this case, there is no such point to discuss about it. That is why we are not taking 1 as well. But here we can take 1. There is no such restriction to taking 1. But since this will become constant function, that is why I am not taking 1 here. But in the case of 0, whenever you are taking x is equals to 0, it is becoming this, which is not defined. Okay?
Okay, sir.
Okay. That is why we are excluding 0 here. So in this case, we are not taking 1. Why? Because when we will take 1, this function will become constant function. And then after that, there is no such point to discuss about it. Okay. So exponential function defined as like this, where a is greater than 0 and a is not equal to 1. So in this case, two cases occurs. Case 1, where a is strictly greater than 0, and case 2, sorry, strictly greater than 0 and less than 1. And case 2, where a is greater than 1, right?
Yes.
Or you can write it as like this. Like 0 is less than a is strictly less than 1. These two cases will come into the picture. Okay. Before discussing about this two case, I will discuss about domain, because I'm defining a function. So there will be some domain. There will be some codomain. There will be some range, right? Right? So here, what is your input? Input is your x. And I am already seeing here your x is coming from R. So in this case, your domain will be equal to what? R only?
Yes, sir.
Right? Okay. What about codomain? Codomain is always R. We can take codomain whatever we want. Okay. What about its range?
0 to infinite.
0 to infinity.
Why?
Because, sir,
Because sir, it can only be positive, the output.
sir, yes, sir. A is greater than
Yeah, exactly.
greater than 0. Sir.
Okay.
That's
Yeah,
why
exactly.
A is 0.
Exactly. So the range will become 0 to infinity. Okay. For this case, okay, if you will translate this function like this, a plus 1 raised to power x kind of thing, or you are saying ax plus 1 kind of thing. In this case, the range will be differ, but in this case, the range will be 0 to infinity. Okay.
Okay, sir.
So this is the basic thing that we need to conclude. Okay. After that, let's move to the graph. How the graph will look like for this case. Okay. So when the case 1 will start, so in the case 1 where, see, I am not showing how this graph is making. Okay. I am just representing what is the graph, because this is not so important for you, and as well as this will take some time. Okay, before understanding how this graph is making, you have to learn about concept of limits and all. Okay.
Excuse me, sir. Is there a session planned for tomorrow?
Yeah.
Because it's not showing up in our calendar. In our calendar, there's a
Don't worry, don't worry about it, because that session was not planned initially. I asked to them for the tomorrow's session, because I don't think so the whole thing from week 5 to 9 will cover in one session. Okay.
Okay, so in which case,
That
the
is why
same link that we use today, we can use it for tomorrow, like will we be provided with a new link?
Most probably they will provide with the new. They will provide new link. Okay.
Okay.
But if there is such case, kind of case, we will inform you.
Okay, the YouTube live will anyways will be open, right? YouTube live will.
Yeah. So some of you guys are watching YouTube live as well, or you all the guys are joining this link only?
No. A lot of people watch through YouTube also. I was initially watching through YouTube, and then I joined because I wanted to ask a doubt.
Okay. I was thinking that in this class only 41 people are there.
No, in YouTube also a lot of people watch.
Okay.
Okay.
So in the case, in this case, this kind of thing. So what kind of graph this thing is? In this case, what kind of graph you will get? You will get, just remember this thing, okay? Right now you are not at this point where you can ask, sir, how this graph is making. Okay, one more thing, your fx is what? A raised to the power x. Okay, so one small thing we can do, where a is less than 1 by 1. Okay, so assume a particular value, say a is equals to 1 by 2. So in this case, your fx will become half raised to the power x, right? Okay, what if when x is equals to 0? When x is equals to 0, it means that I am asking about y-intercept. What it will be?
Sir, 1.
1. In this case, fx is equal to 1, or you will say f0 equal to 1. It means that your graph will cut somewhere here. This is your 0, 1 point. Okay. What if when x goes to infinity?
In that case, this will tend to 0.
This will tend to 0 because if x will go if x will go to x will become larger and larger, this entire thing will become smaller and smaller. Right? It means that whenever x goes to 0, x goes to infinity, your fx will go to 0, right? This is your x is equals to 0 line. Sorry, y is equals to 0 line. Right? Whenever x goes to infinity, your fx, it means that y is goes to 0, right? Now, what about when x is equals to 1? Your fx will equal to half. Right? At x is equals to 1, your fx is half. Suppose your x is equals to 1 is here and your half is here. So somewhere here you will get some point.
Okay.
Now you are getting just. Now what about here? What about when x goes to infinity? Sorry, minus infinity. So it means that your x is negative, right? X is negative. So it will become like this. You know this thing, na? If x, this is equal to this. Right? So in this case, this will become 2 raised to the power y kind of thing, or 2 raised to the power x prime kind of thing. If your x prime is, if x is equals to minus x prime. Okay. So in this case, this will go to infinity. Why? Because if x is going to be minus infinity, if this thing is happening, and your x is going to be minus infinity, it means that this whole thing will go to minus infinity. This whole entire thing will go to what? If in the case of 2 raised to the power infinity x. Okay, let it be. If x is goes to minus infinity in this case, it means that at some point your x will be less than 0. Right?
Yes, sir.
Right? In this case, your x is equal to some minus type of x prime. Okay, this is just a number. This is just a number. It is a positive number and with minus sign.
Sir?
Yes.
So, like rather than saying a is between 0 and 1, we can just say it's a raised to power minus x, right?
No, we can't say. No. We don't know about a, because x can be positive on that point. You are saying this is also true, rather than saying a is less than this and this. Because x is arbitrary. If you take x is equals to 2 minus 2, what you will get? You will get a raised to the power 2. Here in this case, you can take a is equals to 2 as well, or a is equals to e as well. What you will do, and that guys cannot say anything about this a, right?
Got it, sir.
By this manner. Okay. Okay, so what I am basically saying, I am saying if x is negative, it means that it will be minus of some positive number. See, similar, just like this is your 0, here this is your minus 1. So if -1 is less than 0, it means that this is -1. Is 1 with minus sign.
So you're saying coming to the numerator pretty much, right? Like
yeah, exactly. That's what I want to try to convey. Okay, so all the negative numbers is essentially a positive number with minus sign, right?
Yes, sir.
Right?
Yes,
So
sir.
if x is less than 0, it means that there is some positive number x prime whose negation of if you will take with minus sign with this positive number, you will get this x, right? If x is negative. So just put x is equals to this here. What you will get? 2 raised to the power minus x prime. In this case, you will get 2 raised to the power x prime. Now, your x, as x goes to minus infinity, your minus x prime goes to infinity. Right? Sorry,
Yes, sir.
your minus x prime is also goes to minus infinity. In this case, your x prime goes to infinity. Right? What I am saying? I am saying your x is equals to minus times of x prime. Here x is goes to minus infinity. This implies minus x prime goes to minus infinity. This implies x prime goes to infinity. Got it?
Got it, sir.
Okay. So in this case, if x goes to infinity, this entire term will go to infinity.
Yes, sir.
Okay. So for this case, whenever I am taking here x goes to minus infinity, your x prime is goes to infinity. Then your graph will be go like this. This is the graph a raised to the power x whenever this thing is happening. Okay. Similarly, you can check for case 2. Okay.
A is greater than 1.
So in this case, your graph will be look like this. Okay. A raised to the power. A is greater than 1, not 0. Okay. What is a similar way you can check? So remember this thing. This thing will be very important. Okay. Okay.
Okay, sir.
Okay. So what is your y-intercept here? Both case?
1.
It will be 0, 1.
Yes.
What about x-intercept?
Nil. Nil.
Nothing?
Asymptote.
Nothing? Or nil, you can say.
Yes, sir.
And this line will become your horizontal asymptote. What is asymptote?
Yes,
What is asymptote? Asymptote means a line is said to be asymptote of a curve if it touches in the infinity. Here you can see this will touch to the infinity. I don't know where it will touch, but somewhere it will touch. That I know.
Okay.
Okay.
That is called asymptote.
Okay. After that, what is end behavior? I have already explained. Then roots, no roots are there because x-intercept is nothing. And then increasing, decreasing. Okay. So in this case, function is strictly decreasing. And since it is strictly decreasing, it is 1, 1 as well.
Yes, sir. 1, 1.
Right? In this case, function is strictly increasing. And since it is strictly increasing, it is 1, 1 as well.
Yes, sir.
Okay.
Yes, sir. Yes.
Now what else? Domain is done, range is done. And behavior done.
So, but the graph of a like a minus x and like between those will be kind of same, right? Though a is not.
It depends on what is the value of a. In this case, if your a is less than 1 and greater than 0, Okay, so in this case, your graph will look like this, because this is not a raised to the power minus x is nothing but 1 by x, 1 by a raised to the power x here. Now see, if a is less than 1, then 1 by a is greater than 1.
Yes, sir.
So in this case, this is nothing but this is equal to b, where b is greater than 1, and this will become your b raised to the power x. In this case, your graph will be look like this. Okay.
So I'm having confusion with respect to logarithmic. I guess I will come to it later.
Okay.
Discuss it.
You got my point here?
Yes, yes, sir.
Okay. Okay, after that, and behavior is done. Okay. Okay, after that, natural exponential come into the picture. Okay, basically, natural exponential is nothing but there is nothing. Okay, there are some laws that I did not mention here. Okay, before starting this natural, there are some laws. Okay, that laws I think you have to study. So for ST belongs to R and AB greater than 0. This is important formulas. This will be very helpful for solving the question. A raised to the power S, A raised to the power T is equals to A raised to the power S plus T. This is easy actually, not so. A raised to the power. I am just writing it.
Sir, I think there are 9th class problems.
Sir?
Yes.
Sir, for this particular one, second one, if it is written AST without the bracket, like we should always, yes, like without the bracket, AS raised to power T, like we should always scare the S, right? Like we should always.
Sorry?
Let's say.
You are saying if it is written as like this.
Not A S raised to power T.
A S raised to the power T.
Yes, without the bracket. We should always take this as S, like we should always scare like S raised to.
Firstly, you will calculate this, then you will calculate this. In this case, what is happening here? Here, firstly, you are calculating A raised to the power S, then you are taking the power T.
Yes. Okay, sir.
Okay. In this case, you are firstly calculating this term, and then you are taking the power of this. Suppose this is your M, then you are calculating A raised to the power M.
Got it.
Got it? This thing, and this thing totally different.
Yes, sir.
Remember this thing.
Excuse me, sir.
Yes.
Can you take any example of exponential function?
Any example? This is the example. Now you can say 2 raised to the power x. This is the example. You can say 1 by 2 raised to the power x. This is the basic structure of, see, this is the basic structure of exponential function or standard form of exponential function. If you will put some value of exponent a, then you will see what is the exponential. So what I will suggest you, just go through the any graph making app, and then put a function as a raised to the power x, and then apply the value of a. Okay, and then see how is going.
Okay, sir.
Okay, or in the end of the class, I will show you
Okay.
how it is behaving actually. So it will become a raised to the power s, b raised to the power s, fourth one. Do I have to write all the formulas?
No, sir.
You already have, right?
Yes, sir.
Yes, sir.
We have PDF.
Okay, okay, thank you so much. Otherwise, it will take lots of my time. Okay, so what is natural? Natural exponent. It is nothing but if you will take a is equals to e. Okay, this is known as Euler constant. If you will take this a is equals to e, this is an irrational number. Known as Euler's constant, and if you will take here e, then your function will become fx is equals to e raised to the power x. and here E is always greater than 0, whose value is approximately 2.71 something. Okay, I don't know anyone don't know the exact value because it's an irrational number. So in this case, this function is known as natural exponent function. Okay, so what will be the graph of this function? See, E is greater than 1, then the graph of this function will look like this. Okay. So basically, this function is used for getting interest kind of thing, interest rate kind of thing. So that formula, have you remember or not? R by T kind of thing, R by 100 raised to the power RT. This is if you want to calculate that compound interest. So basically, 1 plus this 1 by n raised to the power n. This function is converging to this, or if you will take x here, this function is converged to e raised to the power x. Okay, when n is increasing, n is getting larger and larger, then this will work as exponential function. That kind of thing is for further process. So remember how you can calculate that compound interest part. That will become. I think that there are some questions from your exercise as well. For
Yes,
compound interest. Okay, so just go through that particular question as well. That I have already covered in one of the solve with us session. Okay, so this is the thing in the natural exponent. If you will take a is equals to u, you will get that kind of thing. Similar, all the thing. What is the domain? What is the codomain for that? That is the proper thing is there. Like this is the basic thing as there. So here I have already mentioned for a. What is the value? Same as E you can take. So this is easy, not so difficult. But yeah, one question is coming from that compound interest calculating. So please go through that particular question as well. Now, after that, the composition of a function is coming to the picture. This is starting the new week, okay? Or this week only.
Sir, I think composition was before this, and after this it was logarithmic.
Yeah. Okay, this is the week 5 only. Okay, so what is composition basically? Composition of function. What is composition? Can someone tell me what is composition means?
When there is a function inside a function.
No. Basic
So basically, the argument of a function is another function.
No. I'm just saying, what is the English dictionary meaning of composition?
Like combination.
So
or grouping.
When a output of one function goes to another function, no.
I'm just saying, what is the dictionary mean of composition, not mathematically. Grouping, okay? That kind of thing is that you can combining the items, combining the thing. So what basically we are doing here, did you seen that relay race?
Yes,
Did you ever seen that relay race? This is your ground, suppose. Okay, so in that relay race, what kind of thing there? There are some stoppage kind of thing. Okay, that kind of thing is stoppage. And in the each stoppage, there will be some person. If you have seen that movie, what is that? Chichore. So in the last part, in the climax scene, there was one person. What is it names? I forgot actually. That senior one. Okay, his there will be some like in that race. Basically, I forgot that movie. I did not remember exactly. So in this race, what is happening here? Basically, this person will take a flag. Okay, the referee will give him a flag, and then once he got a flag, he will once the whistle will blow, this person is start running. start running. And when this person reach here, this person will give that flag to him, and then this person will start running, and this thing is going accordingly, right?
Yes.
That you have seen in relay race. So once this function approach this point, this function will give its, once this person will approach this point, this person will give its flag to him. Then from here, this function, yeah, direct. Okay. So this function will start, sorry, this person will start running, and then this thing will simultaneously happen. Okay, similarly in the case of composition, suppose this is your set A, this is your set B. Here I am taking all the sets non-empty, okay? This is your set A, this is your set B, this is your set C. Okay, suppose some function is defined from here to here, f, and another function is defined from here to here. Okay, so what is the composition of this function? It is denoted by this FOG, not FOG. In this case, this will be denoted by GOF. Okay, this is composite, and this is known as GOF of x. Okay, why I am not using this, I will explain. Okay, this definition is sorry. Okay, this is implies this. So what is, firstly, the x will start learning. Okay, this function f will take x, and then this function will start running, and then this person approaches this point, and after approaching, this will convert to fx, and then your g will take this fx, and then he will start running towards c. And when this function will reach to c, this will become this. You got my point?
Yes, sir.
You got my point? So in this case, what is going on here? Here, firstly, initially we are starting with x. Then after that, this f is operating this x. Then after operating this f, this x will become fx. Then in this fx, g is operating again, and then this whole thing will become g of f of x. And this thing is also denoted by GOF of x. You got my point? What is the motivation behind this composition? Similar as relay race. Okay. So now, what are the sets you can say? If you will include one more set here, then after that this thing will happen. Then you will say, yeah, you are saying h of g of f of x. You are getting my point? What is going on here especially?
Yes, sir.
Exactly. Now, my question is, suppose, let's talk about domain of this. Okay, you got that particular thing now? So I should I write that formal definition of f of g of f, or composition of a function, or I will directly move towards the domain? If you are able to understand that definition.
So you can move to domain.
I can directly move to domain. If someone wants to write that particular, like if someone wants me to write that definition, I will write.
Please write and continue.
Okay. Okay. So what is the definition? So the composition of a function. Okay, here we are talking about only two functions. Here, this race, only 2% will be there for you guys. Okay. Okay. So let f is defined from A to B, and g is defined from B to C. Then the composition of a function of functions f and g or sorry, G and F. Okay, because here I am taking, I am firstly operating F and then operating G. So G and F is denoted by GOF and defined as, see, simple thing is there, GOF of X is equals to G of F of X. Got it? Okay, this is the formal definition of composition of a function. So similar thing is there. Firstly, this F will operate on this X, the inputs of this A, and then whatever output you will get, on that output this function G will operate. Okay?
Okay.
Okay, this is the definition. Okay, let's talk about the domain, because this is important. Suppose this is your A, this is your B, and this is your C. Now, can someone quickly tell me, if I will not give, suppose this is X, F, and this C. Okay, suppose if I will not give any flag to this person, if this relay race is happening here, and two persons are there, here and here. If this person A, P1, this is person P2. If I will not give any flag to this person, no matter how much fast this will run, this person will run, this person cannot start running, right?
Yes.
Because this person will start running only when this person will get flagged by this person. Right?
Yes, sir.
If I will not give any flag to this person cannot run. Similarly, if some x naught is not inside the domain of this function, if some x naught is not inside the domain of this function, this entire thing cannot inside the domain of this function. Right?
Yes, sir.
You are getting my point? Similarly, if I will not give any flag to this person cannot pass that flag to the person, and this person cannot run.
Yes,
Right?
sir.
So for the domain of GOF, there will be two conditions. One condition is, firstly, if first condition is saying, if X does not belongs to domain of F, this implies X cannot be belongs to domain of GOF, right? Right?
Yes, sir.
You are getting my point. If I am not, if someone is not coming to this domain, this one cannot be coming for the entire domain of this. Right?
Yes, sir.
Right? Similarly, as if I will not give any flag to this person cannot pass that flag to this person, and this after that this function cannot run.
Yes, sir.
Right? So the first condition is here. Okay. Now again I am saying, suppose this person is running. Okay. And this person is passing a different thing. sorry for that. Okay, just a minute. Okay, let's start. Okay, if I will give flag to this person, okay, and this person is started running, and this person stopped here, and this person is not moving, then does this person will start run?
No.
That I will cover, Vishnu. Okay. Okay. Further I will take. Okay. So what I am saying, if P1, I will give the function. It means that your x0 is inside domain now. And your fx0 is not inside the domain of this G. It means that if your fx0, it means that the flag, the P1 is started running. I give you that flag and this P1 is started running and this person is stop here. Okay, it means that this person did not give any flag to this person. Does this person will start run?
No, sir.
No, right? Similarly, if your fx0 is not inside domain of G, then your fx0, sorry, then your x0 cannot be inside domain of GOF. Okay, got my point?
Yes, sir.
Okay. Similarly, the second condition is saying if fx0 is not inside domain of G, this implies x0 will not inside domain of GOF. Got it? Easy?
Yes, sir.
Okay. So what kind of question they will ask? They will ask, suppose you have fx is equals to 2 by x minus 1 and gx is equals to 3 by x. And they will say, what is the domain? What is the domain of GOF or FOG? Okay, so most of the student will commit that mistake. They will firstly calculate GOF. GOF is what? GOF is nothing but G of f of x. This is what? What is your GX? This. Just put so what is G of f of x will be? This will become 2 by x minus 1, right? I have to put fx in place of this x, right?
Yes, sir.
Right? Sir, if is it right or wrong? If FOG is inverse of GOF, what is the statement, Vishnu? Can you clear that statement? Okay, so this will become 3 by 2 into x minus 1. Okay, so what they will commit that mistake? They will firstly calculate this and then they will find the domain of this function. Okay, but that is totally incorrect. If you want to find the domain of composition, you have to check these two conditions. Whether this x is coming inside domain of f or not, and whether this fx not, if x is coming this domain of f, then this fx is coming inside domain of G or not. Okay, take x here. Okay, I mean FOG is the inverse of GOF. Is it correct? No, not necessary. Okay. There is no such possibility that if FOG is defined, we cannot say anything about GOF. GOF can be defined, cannot be defined. I will give you that example as well. Okay.
Sir,
So in
while finding the domain of a composite function, we just need to ensure that the set
this
of
two
all x
condition will
should,
satisfy.
yes, that fx should also agree with that domain and gx should also agree with that domain, right?
Yes, exactly. Okay. So what is this f here? Whenever you are calculating this GOF, it means that this is nothing but this is GOF of x. It means that the inside function here and the outside function here. In the second condition, we are using that outside function. Some of you guys will confuse this f of g in the case of f of g and GOF. Most of the person will confuse in these two notation. So if you write this thing for FOG, how will you write? For FOG, how will you write these two conditions? First condition is what? X should be inside domain of G. Here always you will use firstly second thing or inside thing. And the thing is, first condition is this, and the second condition is G of X should be inside domain of f. If these two conditions will satisfy, then only you can say x belongs to domain of FOG. Okay. Similar for this case. Okay. These two implication entirely. Or this is for not belongs to case. Okay. You got my point? Sorry. If this will not happen, this cannot happen. You got my point?
Yes, sir.
Okay. Now, how will I find here? Now here, if I want to discuss about GOF. So what is your GX? Your GX is 3 by x. And what is your FX? Your FX is 2 by x minus 1. Okay. So first condition is saying if x is not belongs to domain of G, then x cannot belong to domain f of G. Okay. So what is equals to 0, right? Right? 0 is not inside the domain of G.
No, sir.
Right? So
Yes, sir.
0 cannot inside the domain of G of f.
Yes, sir.
Right? Now you need to check what is this. If sorry, f of x, for what value of f of f is not inside domain of G. For what value of x, your f of x is not inside domain of G.
1.
Okay. So if you will take x is equals to 1 here, x is equals to 1 here, this is your f of x, right?
Yes,
And you are
sir.
defining. Okay. So, okay, fine. So this is your g of x equal to 3 by x. So here if, okay, firstly I have to check in the
Sir,
domain of
like
f,
basically
right?
3 by x should not be equal to 1, right?
Just a minute. I think I commit some mistake here. I commit some mistake, sorry for that. Basically, in the case of g of f, or you can say g of f of x, first condition is saying this. If x does not belongs to domain of f. Okay, just find the value where x does not belongs to. So here in this case, if x is equals to 1, this will not define. It means that 1 is not inside domain of f. Right? Not 0. 1 is not inside domain of f. Right? Now, if f, sorry, it means that 1 cannot be inside domain of G of. Okay, by first condition. By first condition, I applied first condition and then I got this. 1 cannot be inside G of f. Okay, just applied second condition. Second condition is saying for which value of x, your fx is not inside the domain of G. Okay, so your domain of G is here. What? In the domain of G, your x cannot be equal to 0. Okay, it means that in this case, if you will apply GOF of x, in this case, your x is nothing but your fx only. Right? Your fx will work as input of this G. So in this case, what you need? You need fx is not equal to 0. I need those value of x where for which your fx is getting 0. Why? Because if you will apply g of f, this will equal to g of f of x. This is nothing but this will become 3 by fx. Just replace x by fx. So in this case, if fx will be equal to 0, this function will not define. So that is why I need to confirm that fx is not equal to 0. So when fx is not equal to 0, when 2 by x minus x minus 1 will not equal to 0. Okay. Does this thing will equal to 0 for any value of x? No, right? Whatever value you can take for x, this value cannot be equal to 0.
Yes, sir.
Right? Okay. So this
Sir,
thing
if
is
we
allowed for
directly
all.
find the domain for the composite of a function, so then that would come out to be incorrect, right?
Yeah, that will be incorrect because in this case, I have calculated this composition. In this case, for all value of x, this is defined. But in this case, 1 is already excluded.
But sir, if like the composition of a function is a separate function in itself, right? So
Yeah,
if it is
for that
defined
particular
at 1,
separate function, if they will ask for that particular separate function, then you can go by this manner. But in the case of composition, they will see if they will ask that kind of thing, they will give you two functions and they will say just give me the domain of composition of these two functions. Otherwise, they will directly give you function fx is equals to this 3 by 2x minus 1. Why they will give you two distinct functions?
sir, like if they are asking for the domain of the composite of two functions, then
Yes.
while doing the PYQ, there were some questions in which the correct option was if we had calculated the domain directly of the composition of two functions.
It depends on the function as well.
So,
it depends on the function as well. Suppose you have fx is equals to x and you have gx is equals to x square. In this case, what are the composition you will take? Your domain should be R always.
oh, no, sir, I'm not talking about that. I'm saying that the domain of the separate functions, like if we followed the two conditions, in that case, if the domain is different and if the domain of the composite function, if we take it as a separate function, that is different, then in
Yeah,
that case,
that
if
is
we
different.
get a question that find the domain of the composition of these two functions, then sir,
Then you
which
have to
method
go
should we
by
approach?
this manner. This manner. If they will use that composition word, then you have to go by this manner because for composition, this condition should be satisfied. Okay. If they will give you a separate function, they will make a separate function and they will ask, just give me the domain of this function. Then you can directly go by the finding the definition, how to find that domain of
Okay, sir.
function.
And if in the
Okay.
question it's mentioned like composition or GOF or f of g, then we
Yeah,
need to use
exactly.
this
So
method.
then you need to use this.
Okay, sir.
Yes. So got my point? Here for all value of x, this is satisfying. It means that for domain of f of g, what will be your domain of f of g of f? It will become r minus this 1 only. Because for x is equals to 1, this thing is not holding. Otherwise, for all value of x, this is satisfying. Got it? Okay. Okay.
Sir, I have one doubt, but in the function g of x, our x should not be equal to 0, right? If we take x is equals to 0,
Yes. That is true. But in the I am saying in this case, when this function will run only when this function will come towards this, right? If this function will not go to 0, this person will not have any issue. This person have issue only when the input of this function will become 0. If someone is not becoming 0 at any point, this person does not have any problem. You're getting my point?
Yes, sir.
Okay. Because the input function is not becoming a 0. If this not function not becoming 0, then the output function will not have any problem. The outer function will not have any problem because this function is not becoming 0. So if this function is becoming 0 at some point, that point will be removed. Okay.
So
we will remove that point if this function will becoming 0. Okay. After that inverse function will come into the picture. So what is inverse function actually? So inverse function is nothing but just by this relay race example. Suppose this is your P1 person, this is your P2 person. Okay. In this case, what is going on here? If this person taking flag and this is starting running towards this, and this person have give that flag to this person. And what this person did? This person is going towards this direction and then meet to the initial condition as well. And then that flag will give to that referee. Then this person will become inverse of this, because whatever work this person has done, this person is just erasing that kind of thing, right? Right? If this person is moving 5 steps towards the direction of this person is moving 5 steps in the inverse direction.
Yes, sir. Yes, sir.
Right? This person is erasing all the work, whatever he has done.
Yes, sir.
So that kind of function is known as inverse of a function. Suppose for a function g, there is a function f such that your g of f of x will becoming x only.
Yes, yes, sir.
What I am saying, for a function f, there is a function for which this kind of thing is happening. It means that whatever changes will happen because of this f, that changes will become 0 because of this g. Okay, suppose in this x, f is operating in this x and this will become y1. Now, by the composition, there is a function g for which if you will operate this g on this entire thing, it means that you will operate this g into this y1, you are getting this x initial one. Then this function, and this is happening for all the values of x. Then this function is known as inverse. This function will known as inverse of this f. You got my point? Basically, what this function is doing, this function is erasing all the work done by this function f. You are getting my point?
Yes, I understood.
Understood, right? Easy, right? Okay.
Yes.
So in this case, there are some condition. What is the condition? What will be the domain? Okay. So it does not mean that g of f of x is equals to f of g of x is equals to x. This will not happen. Okay. Remember that thing. This is incorrect. Because in this case, you are getting input, and this input is any something else. This input is something else. How it is? C. This is your A. In this case, you don't need any C. Okay. So this is your function f, and this is your function g. Here it is moving this word. Here it is moving this one. Okay. So this f is taking x1 as input, x0 as input, and giving y0 as output. Okay. And this person is taking y0 as input and giving x0 as output. That kind of thing is happening here. Okay. So in this case, this person is taking inputs from set A, and this person is taking input from this B. Yes?
Yes, sir.
Yes, Vishnu? You want to say something? Okay. Okay, so what's going on here? Here, this function is taking input from this function A, and here this function G is taking input from this function B. Okay. In this case, what we are getting, what I am saying by the definition of inverse function, I am saying if there is a function from this f, G for this f, such that this will equal to x, means that whatever input I have applied for this function, I am getting the same input. And this input will come into this A only, right? Because I am taking input from F.
Yes, sir.
right? But in this case, if I am talking about f o g of x, so in this case, this x is coming from b, right? Because g is taking its input from b, right? In this case, you are getting x, and this x is belonging from this b. So does both x's are equal? No, right? Because one x is coming from this a, one x is coming from this b. So this thing cannot be equal to each other.
Yes, sir.
Right?
Yes.
Got my point? So this is not equal to each other. Okay. Okay. So in this case, your domain x belongs to domain of f, and domain of f is same as range of g. Okay, and this g is denoted at f inverse. If this g will become inverse of f, okay, this is denoted as f inverse. So in this case, rather than using this g, I will use this f only, f inverse only. Okay. Similarly, in this, okay, forget it. So in this case, your x belongs to domain of g, which is same as, sir, I just joined. Are you going to extend this session anymore? This session, like I will finish up to week 7, and then I will again resume the session by tomorrow. Like I will start in the new session, or I will resume this session as well. Whatever thing will happen, I will inform you.
So,
okay.
So, sir, like at what time till this session will be held?
It depends, like how early I can cover all the thing whatever I have planned today.
Oh, sir, currently we are in which week?
Sorry, we are in right now. We are in 5th week, but in the 6th week there is very less thing. But in 5th week there are so many things. That is why it is taking much time. But in week 6 there is less thing, because only logarithmic are there in week 6, and then week 7. For some of the thing I have already covered, like monotone function, that I have already covered. So in week 7, basically you have tangent line and sequence only.
So, sir,
So
today
barely
we
it
will
will
cover
take
till week
1.5.
7, right?
Yeah. Half of
Okay.
the week 7,
Okay,
not
sir.
entirely week 7.
Okay, sir. Please continue.
Please continue, sir.
You just join now?
Yes, sir. I had a Python lecture as well, so that's why.
Okay. Okay. This will be same as range of G inverse here, right? If I am writing something wrong, please correct me. Oh, sorry. F inverse only. Okay. Okay. Plus correct. Range of G or F inverse. Okay. Here, since I am using that F inverse portion here, so this will be domain of F inverse, which is same as range of F. Okay. So basically what I am trying to say here, I am trying to say what is the domain of F here. In the case of inverse function, the domain of F is exactly same as range of G or range of F inverse, and domain of F inverse is exactly same as range of F. That thing I want to confirm. Okay, just remember this thing. Why so? Because this function is invertible. It means that this function is bijective. It means that this function will become 1, 1 and on 2. If it is become 1, 1 and on 2, this thing will happen. Okay. Now, okay, one more thing. one more thing, that graph of f and f inverse. What is the difference? So basically, see, if AFA is the point, is the graph point of the graph of this function, then for this function, FA and A will become graph, right? Right. So basically, if this is the graph of your F, and this is your point AFA, it means that this is your A and this point is your FA. Then FA, A will become your point of F inverse, right? It means that the same distance what I have taken here, this will become here only. Here, somewhere here. So here you will get FA, and here somewhere here you will get A. So this point will become your FAA. So your graph will be look like this. This is for F inverse. You're getting my point? And suppose this is your line y is equals to x. You're getting? So basically, in the case of inverse function, sorry, huh? In the case of inverse function, the graph of the inverse function is symmetric to the the line y is equals to x. Okay, symmetric across the line y is equals to x. So suppose they will give you this function. This is what fx is equals to x cube. And what will be the graph of fx is equals to y cube? Fx is equals to, what is the graph of f inverse? Suppose this is the y is equals to x line. So this will become like this, right? Symmetric. So after some point, this will take over this line. Okay, so this will become your f inverse, x raised to the power 1 by cube. You're getting my point or not? Okay. Hello.
Yes.
Right. So the graph of the inverse function is symmetric across the y is equals to x line. Why so? Because this thing I have concluded. If f for f, this is the point, for your f inverse, this will become your point. Now, if now up to this week 5 is end. So from here week 6 is started. So here in this portion I will cover logarithmic. Okay, logarithmic, and then there is no such thing for logarithmic, less thing. Okay, then after that I will start week 7. Okay, so there are less thing in logarithmic, no such thing. Okay, so what is logarithmic function basically? Someone has some doubt in this, right?
Yes, sir.
Please ask after.
Yes.
What is logarithmic function?
It's the inverse of exponential.
Yeah, it's the inverse of exponential function. That's true. The logarithmic function to the base A is defined as fx is equals to log ax. Okay, where this is base. This is known as base. Okay, so basically, if you have log ax is equals to y, this implies that a raised to the pi y will become equal to x. Okay, So this is the basic definition. If this thing is happen, then how can you write this y in terms of this a and x? That thing is calculated by this logarithmic function. Okay, you're getting my point, sir? I just joined. Okay, this thing is okay. You are getting my point. Basically, how will you write this y in terms of this a and x?
Yes, sir.
This is the this is not how will you write? With the help of this logarithmic thing. Okay, so whenever you are writing this thing, you can write this y as like this, and similar, what are the constraints are there in this way, in this particular thing, all the constraint will be happen here. Like your a should be greater than 0, your a will not equal to be 1. Okay, and one extra constraint will again will come here, that x will be greater than 0. Why so? Because this will not, this a raised to the power will not be less than or equal to be 0. Right? This a raised to the power y is always greater than 0. Right? And this a raised to the power y is what? This is x only. You are getting my point?
Yes, sir.
So what are the condition? Condition is, firstly, a is greater than 0. Secondly, x is greater than 0. This condition is coming from here, because if you are defining exponent here, your a should be greater than 0, and this x is greater than 0 is coming from here, because whenever you will define this kind of term, your x cannot be less than or equal to 0. It is always greater than 0. You're getting my point? So this is nothing but this is just this is just a way by you can calculate this y. In this way you can calculate this y, and whenever I will write this thing as in terms of function, this function is known as logarithmic function. And according to this condition, what will be your domain?
Positive numbers only. Sorry, x greater than
x greater than 0. This will become your domain.
Yeah.
Okay. And what about range? Because here
the real numbers.
Here you are saying this y, and in this case, this y can take any value, right? Here
Yes.
this y can take any value, right? So here this y also can take any value. So in this case, range will become your entire real line. Okay, for this function only, for this specific function. Okay, you are getting that concept of logarithmic.
Yes, sir.
Okay, so someone has some doubt on this, please ask.
So basically, I have like doubt in let's say we have ex, right? So when we graph
e raised to the power x.
So when we graph like the ex, so then the logarithm, like the inverse logarithmic x.
This will be like this. Okay. This will be like this.
Then we have e raised to power minus x.
E raised to the power minus x, yes.
And
then
how do we represent the logarithm, like the inverse for this?
Okay, so e raised to the power minus x is basically this, right?
Yes,
this
sir.
is the graph for e raised to the power minus x.
Yes, sir.
Right?
Like, sir,
so
I
in
get
this case,
how it's
just
graph.
reflect this graph. Just reflect this graph according to this axis. So here, this the reflection of this line will become your this line, and the reflection of this line will become your reflection of this line.
So that part I get it, but how do we represent it like algebraically?
Algebraically. Okay. So let's see.
Sir, the
how will you
downward part
represent.
would go to the right, right?
Sir, it would be little bit different.
Sorry.
That the line below x-axis would go towards right.
Sir, the y-axis, like on the top, will be asymptote, I think, for e raised to power minus x.
Okay. Yeah. Let's see. So what is your doubt basically?
So, sir, how do we represent like the inverse for this?
You want to represent inverse of this, right? Just take it y.
Okay.
Okay. So this is basically what? Right?
Yes, sir.
This thing can be written as like this. Okay. Just a minute.
Minus x.
Just a minute, okay? Okay, wait for 2 minutes, okay? Okay. So what was the doubt? In this case, how will you write its inverse, right?
Yes, sir. So I got it like the way you explained, like I solved it myself.
Solve it?
Yes, sir.
Okay, let us explain. Okay, so in this case, if a raised to the power y is equals to x here, how will you write this y? This y will become your inverse. So how will you write this y? Log a x, right? So in this case, this a is coming to the base. What is a here? Log 1 by e, right? This is your base. Then y, then is equals to x. This will become your inverse. Okay?
Yes, sir.
Okay, or you can do by, you have one formula for this as well, right? If log a inverse y, you can write it as like 1 by something kind of thing. That kind of formula, I forgot that. I did not remember that formula, but you can write it as like this, right?
Uh, yes, sir. Yes, sir.
Okay. So Chinu has shared some graphs. Okay. I will share that screen.
So it's me only, sir. I was just posting the all the jumble it creates.
Are you able to see this? This portion? Hello?
No, sir, not the graphs.
Graph is not showing. Okay. Okay, let's see. Now are you able to see? I cannot write here. Okay, let me see.
Yes, sir.
Yeah. Now here see, this e raised to the power x is what? This blue part. This is your e raised to the power x. Now this is, suppose this is your what? Y is equals to x line. Okay. Y is equals to x line. Then what is its reflection? Its reflection is this purple line. So this is your ln. Is that
Red line.
the red line? Yes. Okay. This red line. This is your reflection by this line. So that was correct, right? That was correct, right?
So E.
This was correct, right?
Sir, I don't think I at E
Sir,
or minus x.
Oh, this is
yeah.
e raised to the power minus x. This is for
Yeah.
ln x. Okay, okay. Okay, okay. Got it, got it, got it.
Yeah.
Okay. So for that, the graph is different. So how will you make this graph? This graph is look like, yeah. So if you are, okay, I will use this different color. So this is your graph of e raised to the power minus x. Okay. So let's use different color. Then, oh, ln e raised to the power minus x, how will you look like? This will go like this, right? For this reflection, this will go like this, the reflection of this line, and the reflection of this line will look like this. So this will become your log 1 by ex. Now, got it?
Yes,
Is
sir.
this correct now?
Yes.
Is this correct now? This is
Yeah.
incorrect. Okay. Is this correct now?
Yes,
So
sir.
you can see the reflection of this line will become your this reflection, and the reflection of this line will become this reflection. Okay.
Sir, I have a question. Just a second. I'm posting it.
Yeah, just post.
Sir, I posted it in the chat. So there is a function log of mod of x.
Mod x. Yes.
And so I'm wondering about the third option, the inverse of this
Okay,
will.
let me show this function. Okay. Everyone is able to see this question?
Yes.
Yes, sir.
Okay. So what is the problem? In the third option, this, what is the inverse? Firstly, my question is, does the inverse of this function exist?
Yes, sir.
Mod x is what? Your mod x is look like this. Means that it will give you all the positive value only.
Yes, sir.
Right? For the greater than 0, when x is greater than x is equals to 0, what is the value of log x? ln x?
It's not defined.
Not defined. Okay.
Minus infinity, like it goes to.
Sorry.
It goes to minus.
See, this. Okay. Let's see. When x is equals to 1, okay, if your x is greater than 1, your function will go like this only, right? ln mod x.
Yes, sir.
Because your mod x is defined how? Your mod x is x and minus x when x is greater than 0, when x is less than 0. I am saying when x is greater than 1, how will it look like? When x is greater than 1, it will be greater than 0 as well. Okay, so for that, this ln mod x will behave like ln x only.
Yes, sir.
right? So what I am essentially saying,
So you
I
meant
am
x
saying,
greater than 0, I think.
okay, yes, this ln x, just split it. Ln x, okay, and ln minus x. When x is greater than 0, when x is less than 0, remember this thing. Whenever I will take here x is less than 0, it means that your x is already negative and you are putting minus sign here. It means that the entire thing will be positive. Okay? Okay, this entire thing will be positive. So whenever your x is greater than 0, x is greater than 0, your this ln mod x will behave like x is greater than 1. Okay. Now I am saying just put x is equals to 1 and x is equals to minus 1 here. What you will get? You will get ln 1 only. Okay, forget about this. Just put x is equals to 2 and x is equals to minus 2 here. You will get you will get same value, right? This will equal to ln 2 only.
Yes, sir.
Yes. So it means that you are getting two distinct points for which the functional value is same.
Yes, sir.
It means that this function is not 1, 1. It means that the function, the inverse of a function will not exist. It means
Yes.
that this is incorrect.
Okay, okay. I got it.
Got it?
Yes, sir.
Okay. Let's move further. We have lots of things. I think this lesson will go to 12. Okay, there are some things that I will directly post, like some of the rules, some of the straightforward formula. Let me paste on here.
Sir, I saw this formula.
Yes.
Confirm if
Where you have seen this formula.
so can you like write like
I am just pasting that formula, okay? Otherwise it will take too much of my time. Log 1 property of log. Okay, these are the some properties of log. These are some properties of log that you can easily see because I have already explained in exponent part. So I am not going towards this thing I have already covered. Okay. The increasing decreasing part is also easy. You can directly see because two case will be happen same as that exponential part. If a is greater than 0, the graph will look like this. In this case, the graph will be increasing. And the second case, when 0 is less than a is less than 1, in this case, your graph is look like this. Okay. So in this case, the function will decrease. That kind of thing is here. This thing I have already covered. Okay. Now another thing that I want to insert. Property of log is rules to okay, this thing just check it out. This thing is also I have covered in initially. Now what else? That formula, I don't have that file. Actually, I forgot that file, I guess. Yeah, loss of log. Yeah, got it. Yeah, this one. Okay. Do you want to say anything about this?
so there is one formula, like can I mention that I found it somewhere else. I would just want to confirm it with you.
Which one?
So log, let's say I'm giving an example, log base 8.
That base change formula, are you talking about?
Uh,
Log 8
yeah, let's say x. So
x.
like the base we can convert base to 2 raised to power 3, right? And then we can take the
1 by
3.
3.
So this will become log 2 raised to power 3 x, like the base will become 2 raised to power 3 and x, and
Yes.
then we can take 3 out, like 1 by 3. This is the formula.
Yeah,
And,
this is true. Yeah, this is true.
okay, so this is really formula. So I just wanted to.
This will be very helpful for you as well. Okay, you can search the formula online as well. I have mentioned some, I have forgotten some formula, there may be possibilities. Okay, so there is one base change formula. Base change formula is saying that log AX is also represented as log BX at log BA. Okay, if you want to change your base, you can change by this manner. Okay. This is also important. This is a base change formula. This will help you to solve lots and lots of questions. Yeah, the modified version of change of basis formula. Okay. Now after that, natural log come into the picture. This is same as natural exponent, natural log. Just put a is equals to e here. You will get that natural log. And in this case, natural logarithmic, we will represent it as by ln. This is same as log at base ex. Okay. And what about this? It means that you are taking standard log, which is based on base 10. Okay. This is the basic thing that you need to remember. So wherever they will mention this ln thing, it means that this is log natural. Okay. So this thing is known as standard log or a common log. You can take. Okay, so up to this week 6 end. Is there any question in week 6? Because this is a logarithmic part. So from here, week 7 will start. So I will conclude half of the portion of week 7 today and half of the portion of week 7 tomorrow. Is there anything that you want to ask for week 6 or week 5? Please ask.
No, sir, right now, not.
Okay. If you have some doubts, so then you can ask me tomorrow as well. Okay. There is no such concern.
Okay, sir.
Okay, sir.
Okay. Okay. So in week 7, we will discuss some trigonometric function. Okay. Then arithmetic operation. Then what is the graph, and then tangent line, and then some portion of sequence. So what do you want? Firstly, I will explain that sequence part, or I will explain that trigonometric part. Whatever you want. What do you want from my side? You want me to explain that trigonometric function part or that sequential part? Trigonometric. Trigonometric. Okay. This thing is really enjoyable. If we have more time, I will explain in a more precise way, in the detailed version. That will be very enjoyable actually. Okay. So what is trigonometric function? So basically, I will explain you 3 trigonometric function especially. Fx is equals to sin x, then fx is equals to cos x, and then fx is equals to tan x. And after that, there are 3 more, which is cosec x, then sec x, then cot x. So basically, this is just like this. This is just the reciprocal of this 3 primary trigonometric function. So that is why we will discuss about this. And we will assume, or I will assume that you can solve by this also. You can calculate, you can discuss about this functions as well. Okay. So basically in the exam purpose, they will ask about this function only. If they will ask for this function, you just convert it by this function and you can go by this manner. Okay. So let's discuss about fx is equals to sin x. So this is a function. So there may be possibilities that there will be some domain, there will be some codomain, and there will be some range. So what is the domain of this function?
Whole real line.
All real line. Okay. What about range? See,
-1.
I am just giving you direct thing. Okay. I am not I am not solving you. I am not telling you how you are getting this thing, because it will take too much of time. And this is not so important as well. And codomain, you can take any real line. Okay. So what will be the graph? The graph of sin x will look like this. Like here, it will take 0, then go like this, this. This is the sin x graph. This is the value of pi. This is at pi by 2. It will take its maximum value, which is 1. This thing is already known to you, right?
Yes, sir.
2 pi. That is why I'm not explaining that much. Expending my time. Okay, what about fx is equals to cos x?
Same thing.
Same thing.
The graph will be different.
Okay, the graph will be different, but domain is R. The range will be -1 to 1. And then the graph will be like this. It will start from here, then go like this. Okay, this is your pi by 2. This is your pi. This is your 0. This is your 3 pi by 2. This is your 2 pi. Okay, this is your graph of cos x. What about tan x? What is the domain?
It doesn't have some values like like
Domain
90 degrees and
yeah. So in the domain of f, you
Doesn't
have
have
to
odd multiples.
you have to exclude some points, right? What kind of points it is?
But I think something like odd
N
multiples
plus
of
1, this kind of point, right?
Yeah.
Some pi by 2 thing. Wherever this cos x will become 0. Wherever this cos x will become 0, this will be 0. Why? Because your tan x is also sin x by cos x. So wherever this cos x will become 0, this function will not define. So what are the point where cos x will become 0? That pi by 2, 3 pi by 2. Okay. So basically this point where n is coming from z.
or where sin x becomes 1, right? Same thing.
Sorry.
The
I'm
way
sorry.
xn is odd, I think.
No, I'm saying where sin x becomes 1, we can also say that, right?
Yeah. Here 2n. Sin x will become 1. If sin x will become 1, then your cos x will become 0. Yeah. But we have to define this by denominator now. We don't need to go. In this question, this is happening. If someone will give you this function, then what will you do? 9.
Yes.
No, no?
Yes, sir.
So it is basically 2n plus 1, not n plus 1. You are removing that kind of point for all n belongs to z. Okay. Or 2n minus 1 you can take. Okay. Let me write.
So basically it is odd multiples, I mean.
Yes.
Wherever n takes odd value.
Yeah. This kind of thing. So what will be the graph? Okay. What about range? Entire real line. And how will you make the graph? The graph of this here, suppose you are having minus pi by 2. Here you have pi by 2. This is the portion of class 12th, okay? I am not explaining this thing because this is very trivial, and one more thing, it will take so much of time. Otherwise, I will explain in a more precise way how you are getting this graph kind of thing. Okay, this will be become your 10x graph in between minus pi by 2 to pi by 2. Again, this will start like this and then go like this. This kind of thing is continuously going in the more periodic way. Okay. Don't get me wrong, I am moving fast because this is very trivial. That is why I am not explaining this thing. And you have to remember this thing in your mind. Okay. This is very trivial. Okay. So these all the three trigonometric function. After that, I am inserting one more file here. Okay. So if you need this slide, please message me on my Gmail. Okay. Okay, these are some identities. Or after that, if you need more identities of trigonometric function, then please let me know. I will share some of the identities of trigonometric function, which will be help you to solve the trigonometric function as well. Okay.
Okay, sir.
Some of the identities you have seen, I guess, like if I will write that kind of thing. Sine of A plus B equal to sine A cos B plus cos A sine B. That you have seen before.
Yes.
Those students are
Yes,
not having background from mathematics. All of you guys from mathematics only? Like you are +2 standard, class 1,
Yes,
class
sir.
11 and 12. So that thing you have already seen, right?
Yes, sir.
Okay. So in this course, basically you are doing some other courses, including this course, or this is the only course that you are doing?
Sir, this is the only
Course that you are doing. Okay, like
course I'm doing, sir.
Like this is an online course. Simultaneously, I have opportunity that I can get admission in different college and take some offline course. That kind of thing is happening to you, or you are just taking this course only?
So I am doing another course also.
What kind of
Sir,
course you are doing?
Physics honors.
Okay, physics honors. Nice. Okay, okay. So this is your just part-time kind of thing, right?
Yes, sir.
Okay. So this course is nice actually. If you are see, this is nice when you are taking some inputs from other sources as well. If you are sitting like if you are expecting so many things from this course only, so I don't think so this course will be enough for your improvement. So if you are not looking anything apart from this course, my suggestion is please go through it. There are so many sites where you can learn many of skills. So please develop that data science related skills like Python. Python they will convert, like SQL is there, Prequel is there. So many things are there. Okay. Even I don't have background of that coding part, but my suggestion is please go through it as well. So it will be improve your career as well. Because you have to see the long picture. You cannot see the short term thing. Okay. No, sir, I will just pass this exam, then I will think about it. No. Okay. Because passing the exam is not the only thing that you have to do. You have to get a better job. You have to improve your lifestyle as well. Okay, so whoever is doing this course only, I'm suggesting you, if you want to be a data scientist, if you want to go for the data science course, please go like go for the different sources as well. Because this is the one part that you are doing, right? There are so many things apart from this. If you will know Python before than this course, the rating of this course will be improved, right? And and if it is possible, then take some freelancing work as well. So it will improve your what experience as well. There are so many freelancing website on data science, on Python based project was there. So you can take that project as well if you know Python. Yeah, someone is suggesting that Kaggle. There are so many sites you can search on YouTube as well. So that will be helpful for your future if you want to go for data scientist or data analyst job. Because after this course, you have something to write your CV as well. If you have done that kind of freelancing work, that kind of data science work, so you will earn money from there as well, and it will improve your CV as well. Because companies, see, I am also sitting for the companies, so I know that kind of thing. They will ask student from this different varieties. If you have so many things from other things, then they will hire you. Your possibility will be higher than the other candidate who don't have anything like this. They will not going to hire you if you are a topper. Okay. If you are not a topper and you have some skill, they will definitely hire you. So your skills is matter more than your grades. Okay. So this thing, my suggestion is just go for that also. You have so many times. You are a foundation batch student. You have 4 years. Okay. So you can go by this manner as well. Just go looking forward this thing as well. There are so many things. Python is there, C++ is there, C is there. I know that data science program will take care of those things. But if you will learn this thing before this program, before this starting this all the thing, you will be able to solve all those problems. Those will come in your future in this course as well, and apart from this course as well. Okay, so please try to invest your time there as well. Okay, that was the today's GAN. Okay, let's move towards a graph of a function or arithmetic operation. What is arithmetic operation? Nothing is there. Arithmetic is nothing but if you will add to function, you will get a different function kind of thing. So arithmetic operation is nothing but that addition of a function f plus gx is equals to f of x plus g of x, that kind of thing. That you have already learned. Similarly for negative as well, that f cross g is nothing but f of x into g of x, that kind of thing is there. Okay, then composition is there. Composition, I have already explained you what is it. Then after a division. Division is known as if your gx is not equal to 0 for all x belongs to domain of G, then f by g of x is nothing but f of x divided by g of x. This is the arithmetic thing that you have learned. This is so basic. And then one more thing is scalar multiplication. Scalar multiplication is saying scalar multiplication, nothing but if C belongs to some R, then C dot f of x is nothing but C multiply with f of x. Okay. This all the thing. Then what is the graph? Graph of a function. Can someone tell me what is the graph of a function in R2? Hello. Am I audible?
Yes, sir.
Yes, sir.
Yes. Can someone tell me what is the graph?
It's just the Cartesian Cartesian product. Like
it will be subset of, because it's a function, it means that it will be a relation. If it will be a relation, it will be a subset of Cartesian product. Apart from that,
so it will be just the regular Cartesian like graph, I meant.
okay, suppose function is defined from x to y, or you can say a to b, whatever you want. Okay, now what is the graph? So graph is nothing but it is a set G, or someone will say this gamma of x, gamma of f of x. Okay, This is defined as this pair x f of x. For all x belongs to this x. See, this is a pair form, and since this is a function, it means that this is a relation because this is a rule. Every rule is a relation. So this will become a subset of x cross y. So I am taking all the collection of these points and I am saying this will become your graph. So if I will see graphically, so what is it means? What is the graph means? Yeah, path moving points. Yeah, that is also true. This x square, then you have the graph of function this x square like. So what is this graph actually? According to this function, how the point is moving according to this person, that the path of that point is a graph, means that what you are saying, you are taking all the collection of points. You are all taking all the collection of points like x in with respect to this x. What are the functional value you are taking this? You are taking collection of all the points, right? Suppose here you have 1. So you are taking 1 here. 1 and f of 1 is 1. So this is your 1 point. Suppose you have 2. So you are taking 2 and f of 2 is what? 4. So here you are getting some 2, 4 point. So you are getting all the points. You are taking all the collection of points in this graph. Right? Of this kind of thing. Right?
Yes, sir.
So whenever you have to see, you have seen this thing in your choti classes, right? If you have some fx is equals to that x cube type of graph, then you will make that kind of table. Okay, sorry for this table. So here you are taking input and you are getting output. That kind of thing. Or suppose your x fx, then you will take some value -1, say -1, and then according to that -1, what you are taking in this, then 0, 0, 1 kind of thing. And how you are making? You are pointing out this point, suppose this, and this, and you are making the graph like this. You are connecting all those points, right? This kind of thing happen in your choti classes.
Yes, sir.
Right? So similarly, initially what we are doing, we don't know on that point because we are not able to find out this kind of thing. But at this point of moment, what we are doing actually, we are collecting all the input and output thing, right? Right? We are collecting all the input and output thing. And this is what? This is just a representation of this kind of thing, this kind of points in the Cartesian product, in the Cartesian plane.
Yes.
Right? So basically, if I am able to see what is this, this is basically a collection of all the point of like this only.
Yes, sir.
Right? So your graph is what? Your graph is nothing but this is the collection of this. And we have seen what this collection is also a subset of this one.
Yes.
Right? So here I am talking about graph of the function. Then what is the curve? Suppose you don't have function, you have relation just like this. X square plus y square is equals to a square. This is the relation of this now. This is not a function. Then this thing is known as curve. If you have relation in place of function, then the path of moving points according to this equation is known as curve. Okay. In general, graph we will use for function and curve we will use in general. Got my point?
Yes, sir.
Okay. This is also a collection of that kind of thing for relation. Okay. Easy peasy.
Yes, sir.
Yes.
Okay. Okay. Then what is tangent line? Tangent line. What is tangent line? Tangent line is nothing. Tangent line at a point. Okay, at a point. So suppose you have this curve, or you have this graph. I am saying what is the tangent line of this point P? What it will be? I am drawing a line like this. this. And after drawing this line, I got a line where this line just touch to this graph. Just touch to this graph once and then move forward. Right? What I am doing here, I am just drawing this line kind of thing. I need this point. I am drawing the line like this. And then after some times, I will got a line like this, where this line is just touching this graph. Then this line will call it tangent line. So, and then how will you got that tangent line? You will got by approaching method. What is that approaching method? Suppose this is your curve. This is your curve, and you need to find the tangent line of this point P. So what you will do? You will take this line, then just take this line, this line, this line, this line, and once you will just touch once at this point, that will become your tangent line. Okay, you're getting my point?
Yes, sir.
So tangent line is nothing but basically basically what it is just a line which just touch a graph. It is not intersecting that graph. Okay, it just touching the graph and then moving forward. Okay.
Yes, sir. Yes, sir.
Okay. So what is tangent line? What? So what is tangent line? Tangent line of f of a function. It is nothing but at that point of a function at a point A. Yeah, that also you can say, but that we can say when we will discuss about differentiability, we will discuss this thing in a more precise way. Okay, instantaneous change, you can say, instantaneous direction, you can say. Okay, that is instantaneous change. Instantaneous change is also that is derivative, that kind of thing, where derivative is thing. Then we will know this tangent line by that instantaneous change, or tangent function. We will introduce tangent function there. Okay, then we will say, yeah, this will become your instantaneous change. This will represent the instant change of your function. Okay, so basically, just for your knowledge person, I am just saying this is just a line where this just touch the function on that point. Okay, sometimes you are not able to draw this line. In this case, this function here, you cannot draw a line which just touch a function, right? Because if you want to draw by this line, here you have infinitely many intersections. If you want to draw by this line, you have infinitely many intersections. Right? Okay. So
Yes.
what is the tangent line of a f at a point? So it is nothing but tangent line of that curve, or it is nothing but tangent line of a graph at that point. Okay. Okay. If you have graph, you can find that tangent line, right? So tangent line of a function is what? Just make a graph of that function and take that point and then see what is the tangent line of that point on this graph. So what are the tangent line on those graph will be, that will become your tangent line of a function on that point. Understood?
Yes, sir.
Okay. This will also not coming into the exam, that because this portion, they just touch the portion, because there are broadly this portion is so large and large. Okay, so if you want to make some question from this portion, you have to know more about it. So I don't think so they will ask some question from this, but still you have some knowledge about it. Okay, you have to study about it. If they will ask, then What will you do? I am not saying, but the possibility of asking the question from this topic is very less. Okay, after that, sequence part is coming to the picture. This is the last topic of today's session. Okay, sequence. Can someone tell me what do you know about sequence? Hello.
Sir, it is a limit, like it gets to some value.
No, I am talking about sequence. I'm not talking about limit kind.
It's countable. It starts from natural numbers.
Actually, what is sequence actually? You have some sets. Okay, you have some set A. When we will say there is a sequence of this set. So we are just arranging the elements of sequence according some order. Okay, suppose your element A has 1, 2. So I am arranging this 1, 2, 1, 2, 1, 2 kind of thing. This is the order for which I am arranging the element of A. Right? I can arrange by this manner also. 2, 2, 2, 2. I don't want to take this one.
Yes, sir.
Okay, I can take 1, 1, 1, 1 as well. I can take 2, 1, 2, 1, 2, 1. I can take 2, 2, 2, 1, 1, 1. That kind of thing. So I am arranging the elements of A, right?
Yes, sir.
Yeah, this is also a pattern, right? It has to have a pattern. Not necessarily. Not necessarily pattern. Okay. But there is some. I will let you know what kind of pattern you are talking about. Okay, Kumar. I will just let you know. I am just giving you intuition of a sequence. What is sequence actually? So what you are seeing here, this is just the mapping of 1 to 1, 2 to 2, then 3 to 1, 4 to 1. I'm just talking about this place. This is A1 place, this is A2 place, this is A3 place, this is A5 place, this is A6 place. Then 1 is mapping to A1, 2 is mapping to A2, 3 is mapping to A3, 4 is mapping to A5, A4. That kind of thing is happening here. In terms of position, I'm not talking about in terms of element.
Yes, sir. Yes.
Right?
Yes, sir.
So basically, if you are sequence is generally represented as Sn or An, you can say. Suppose for you An. A1, A2, and this kind of thing is here. An kind of thing. So what is this basically? This is just a bijection from this natural number, right? Natural number excluding 0. Okay. This is just a bijection from there.
Yes, sir.
Okay. Understood?
Yes, sir.
So what is sequence actually? What is sequence? No, sequence is not a set. Is this a set? 1, 2, 1, 2, 1, 2. No, right? Because here 1, 2 is repeating so many times. Sequence is not a set in general because repetition is not allowed in set, but here repetition is allowed. You're getting, Kumar? Okay. So what is sequence actually? From here, I am able to see this is a bijection from this natural number set excluding 0 to this. Right? So sequence is nothing but sequence is the function, not exactly bijection. Okay, here it is a bijection. Here, in this case, if you are taking this A1, A2, AN positions, here it is a bijection. But what about this case? This case, if you are taking function from n excluding 0 to this A, then this is just a function, right? Not a bijection because 1 is taking 1, 3 is taking 1, then 5 is taking 1. This is not 1, 1. So this is not bijection as well. Right? Please answer. Then only I can understand you are understanding or not.
Yes, sir.
Yes, sir.
Okay, please answer. Okay, I know function is defined on, yeah, I am not considering 0. So basically, here, if I am talking about in terms of element, then it's just a function. But if I am talking about in terms of position, then it's a bijection function. So for a set, I will talk about element. So basically, sequence is nothing but it's a function from natural number excluding 0 to that set A. Sequence is nothing but it's just a function. Okay, and according to this function, this function will give you a pattern. Okay, Kumar. If you got some function, then it means that you got a pattern. And what is the pattern? The pattern is that function. You got my point? The
Sir,
sequence
but
is nothing
what
but
is the inputs here? The positioning numbers, no?
the input is positioning number is a totally different thing. The input is your natural number excluding 0, and output you will get output in your set A. Now, in your case, you will take set A as R, real number.
Yes, sir.
Okay. So what will be your output? F1, F2, F3. Now,
Oh, okay.
this
So
will
then,
become your A1, A2, A3 kind of thing.
means arrange a
Okay.
pattern like.
Yeah. And your pattern is given by this function.
Yes, sir. Understood.
Okay. Then
Yes.
this will equal to A1 will equal to F1, A2 will equal to F2, A3 will equal to F3. You got my point? Easy, right?
Yes, sir. Yes, sir.
It is not so tough. It is easy. It's
Yes,
just
sir.
a function. If you have learned about function, you can easily explain about sequence. So,
Yes.
some of the example of sequences 1 by n. So 1 by 2, 1 by 3, 1 by 4. See, this is also function. So these are the example of sequence. You understood the concept of sequence?
Yes, sir.
So sequence is nothing but it's just a function. Okay. Then limits of a sequence is coming to the picture. Before it, there are so many things like increasing sequence, decreasing sequence, all the things according to the function as well, because it is just a function.
Sir,
Yes.
sir, can we like have a sequence like defined manually, like for?
Yeah, you can define.
Okay, sir.
1, 2, 2, 3, 3, 3. Is there any pattern on this?
No, sir.
4, 5, 6, 6, 5, 4. Is there any pattern? No, right? But there will be some function. There will be function who is defining this thing. I don't know right now. But there will be some function. And that function will give you that pattern. You have got my point? You can define manually. But that sequence is defining by some function. I don't know right now that function. Roster expression of a function. But roster expression for roster expression is given by given for set only, right? Right, Kumar? Okay, you can say like that. But this is not a roster expression. This is just representation of a sequence. So you are getting my point. If you have some doubt, please stop. Because this thing is not there in your syllabus. They just start from limit of a sequence only. They did not explain what is sequence. At least in your PDF portion and or in your textbook as well. Right? If I am not wrong.
They talk about sequence and subsequence.
Okay. Okay. So what they discuss? They discuss just function or they discuss there is a pattern on that thing?
No, like there were some questions about like where does the sequence go? Where does the limit?
That is different thing. I'm just talking about is they discuss the definition of sequence. This is the definition of sequence.
Yeah, not in the video, sir, but in the PDF, I guess it was.
PDF I have. I saw PDF. That is why I'm just mentioned this sequence thing. They did not mention in PDF. They directly start from limit of a for sequence.
So can you please discuss about subsequence?
Yeah, I will discuss that thing as well. Okay. After the limit, I will discuss subsequent, or before limit, I will discuss. Okay. So what is subsequence actually? So since sequence is here, it means that it will be a sequence as well. Okay. Yeah, just like subset you can say. So it will be a sequence. Now, what kind of sequence it is? There will be some restriction on this sequence, right? Okay, Shivam is writing something. Sequence in sense of function means for each input of position value, we get the element of sequence. Sir, like A1, A2. Am I correctly understood? Yes. Yes, you are correctly understood, Shivam. Okay. You are correct.
So
okay, so what is yes? Subsequence. I'm
1 1 1
yes.
1, right?
Yeah. Okay. So just let me think. How can I explain you subsequence in easier way? Because there is a bijection kind of thing. Okay. Okay, suppose this is your sequence where A1, A2, forget about this thing. I am taking positions. Okay. A and that kind of thing. This is position. Okay. Now I want to make a sequence from this sequence. So how can you take? I will take any increasing order of natural number excluding 0. Okay. Any increasing order. What kind of increasing order? Just like 1, 3, 7, 9. I cannot go backward. I will go always forward. Okay. And I will take their image. F1. Now, here if this is your B1, this is your subsequence, say this, if this is your AN, suppose this is AN prime. If this is your subsequence, take B1. This will be a sequence, you know, right? Since this is a subsequence, sequence is there, it means that it will be a sequence. What kind of sequence? I will let you know.
So we cannot like repeat even one, like A1 A1. That is not allowed, right?
Yeah, that's what I want to say. I am saying. Okay, so what you are saying, you are taking a subset of natural number excluding 0 in a strictly increasing order, like this. It means that you cannot repeat the element and you cannot go backward. If you have taken 7, this person will not become 5. Okay. Okay, in the increasing order. I'm saying in the increasing order, strictly increasing order, not increasing order. Now, take B1 as F1, B2 as what you have taken here, F3, 3, then F3, B3 as F7. You have took this order, right? This will become F7, then B4 will become your F9. You are understanding that thing. This will become your A1. This is your A3. This is your A7. This is your A9. That kind of thing happening according to this order. Okay. Now, what is your sequence AN prime now? It is A1, A3, A7, A9, like that. Then this AN prime will become your subsequence of this. You got my point? So what you need, just take an strictly increasing ordered set of this natural number excluding 0, and according to that sequence make this sequence of this sequence. Okay, so this sequence is known as subsequence of this. Okay, this thing is missing in your that particular thing, that increasing order kind of thing. Okay, why I am taking this increasing order? Because there is two misconception. There is two thing that I cannot do in sequence. I cannot take A1 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 kind of thing, and I cannot take A1 A2 A5, then A3. That thing I cannot take. I have to take this thing in an increasing order only. This subscript in an increasing order only. You are getting my point?
Yes, sir.
Yes, sir.
Easy, right? Not so tough.
No, no, sir.
So for making a subsequence, what you need to see, just check this, since you are defining a function, because subsequence is nothing but it's a sequence. If it is a sequence, it means that there will be a function from a natural number including 0 to that particular thing. So what kind of function? So rather than I am defining this function from here to that particular thing, I am defining a function from an increasing ordered set of this function. Increasing ordered set, strictly increasing ordered set, it means that I will take like this. I cannot repeat 10, and I cannot, if I have taken 7 here, I cannot take 5 here. I will take only strictly greater than element here. And then I will take image accordingly, according to this sequence. Then the new sequence, whatever I get like this, that will become your subsequence. Got it?
Yes, sir.
Okay. For example, if you have 1, 2, 1, 2, that kind of thing, 1, 2. So I can take this 2, this one I have taken, this one I have taken, now this one take, now here take 1, then 2, that kind of thing I have taken. So this will become your subsequent. Understood?
Yes, sir.
So easy, not so tough, right?
No, sir. No, sir.
Okay. Then limit of a sequence. So what is limit of a sequence? See, if an is a sequence, then A belongs to R is said to be limit of a sequence. Okay, what do you mean by this limit? The dictionary meaning.
Boundary of something.
Boundary of something, yes. Or apart from that,
Maximum value.
maximum value, or like if I will say I can expend 500 rupees on that particular thing, it means that that is my maximum limit, right? I cannot expend more than that. What does it mean? It means that whenever I can go far and far, like I can improve, like there if you will sit with your friends, there one kind of thing is going. If you will discuss about your future, then someone is telling, bro, I will earn 1 lakh per month. So someone will come and then he will ask, that is your limit only. That kind of discussion is happening in general, right? Or once in a lifetime, that kind of discussion was happened in your life, right? So what does it mean? It means that whenever time is go, or the time is go larger and larger, where you are approaching, where this f is approaching, okay, you have to see where this f is approaching. In this case, see, since sequence is nothing but your function, so what is limit actually? So limit is nothing but, here is the definition, but if you want to see it in an algebra, like in graphical way, so what is it means? It means that whenever you are taking large and large value of n. Okay, n is nothing but this one, natural number 3, 4, 5. So whenever you are taking large and large value of n, where your function is approaching. Okay, there may be possibility that your function will not approach. There may be possibility that your function will approach 2, 3, 5, 4, 5, 6 values. There may be possibility. So when this value will become limit. Okay, when this value, for example, if you have this function 1, 2, 1, 2, 1, 2.
If there is like an upper bound and a lower bound.
Not exactly upper bound and a lower bound. I will give you that example where upper bound and lower bound will be different and limit will be different. Okay, don't worry about it. So here you can see as n will you will take larger and larger, your function will approach two value, 1 or 2. Okay, here you are approaching two values. It is diverging. I am not saying converging. I am just defining what is limit actually. So if we have to see what is limit, firstly it has to be unique. Okay, because your boundary should be unique, your limit should be unique. That is why that will be that I cannot explain here, because it will take more and more algebraic things, more and more analysis on that. So I'm not telling why it will be unique, but I will give you the intuition that if you are going towards something, then in that neighborhood, like in that neighborhood, everyone knows what is neighborhood, right? Neighborhood, it means in Hindi you can say padosi. Okay.
Yes, sir.
Okay, so in that neighborhood, see, you know one thing, right? For each two distinct real number x1, x2, there will be infinitely many elements, infinitely many numbers, and infinitely many real numbers. Right?
Yes.
Right? So what is this mean? Closer and closer. Closer and closer means if you will take n larger and larger, according to this n, your fn is going towards some number. Like if your number is this L or this A, suppose you, in your case you are taking A, it means that your functional value will lie in the in the pados, as-pados, or you can say in the neighborhood of this A. Okay, what do you mean by neighborhood of this A? Means that it will lie in close of this A. Means that it will go towards A only. Okay, where then you will say this A will become your limit. You're getting my point? No matter in what sense it will go. It can go like this. Like this. Like if this is your A, some value is taking F here, some value is taking here, then here, then here, then here, then here. It can go like this. Or it can go like this way. Or it can go like this way. Okay. Or it will start from here, then it will go like this way. No matter what way it can go, but it has to go towards A only. When n is going to larger and larger, then your sequence an will close to closer and closer to A. Then we will say this A will become your limit. For example, if you have f and or an is equals to 1 by n. In this case, you can easily see 1 is here, 1 by 2 is here, 1 by 3 is somewhere here, 1 by 4 is here. So as you can see, as I am taking n larger and larger, it means that as n goes to infinity, your n is approaching towards 0, right?
Yes, sir.
Yes, sir.
Right? It means
Yes,
that the limit of this sequence will become 0. Okay. What about this 1 raised to the power this? I am giving you different example. Okay. This is your 0. 1 minus.
This will also go to 0.
minus
Okay.
infinity.
Firstly, it will take when n is equals to 1, you will get this minus 1. When n is equals to 2, you will get this 1 by 2. Then when n is equals to 3, you will get 1 by minus 1 by 3. Then 1 by 4. So what is this going? It is starting from here, then going this, then going this, then going this, then going this. Okay. But no matter what pattern it is using, it is going towards 0 only. Are you able to see?
Yes, sir.
Here I am not using any upper bound kind of thing. Here I am just seeing where this sequence is approaching when n is going to infinity. You are getting my point? Another
Yes.
example I will take. I will take suppose fn or an is equals to 1. This is your 1. For all the values of n, your point will be here only. Means that whatever the value you can take, as n is goes to infinity, your fn is or your an is 1 only.
Yes,
right?
sir.
In this case, your limit will be 1. Okay. Now,
Yes.
what about this sequence? 1, 2, 1, 2, 1, 2, 1, and 2. In this case, is there any limit? No, right? I am saying
No, it's not
there is a
divergent.
unique value where your function will approach when s goes to larger and larger. It means that if 1 is the limit, it has to be your all the values of function has to be like this only, either here or here. But for some value, the values are here, and for some value, the values of a sequence here. It means that it does not have any oscillating, you can say, but it does not have any limit, right? Right?
Yes, sir.
Okay. So in this case, we will say this is the oscillating sequence, and this in this way, we will say this is a diverging sequence. Okay. For if a sequence has limit, then we will say it's a converging towards 1. This is a terminology, converging towards 1. Okay, and this will become, if a sequence is not convergent, then that sequence will known as divergent sequence, like this, or you can say like n. In this case, what you will get? 1, 2, 3, 4, 5, 6. So whenever n goes to infinity, your sequence an is also goes to infinity. But infinite is not a real number, so we will say, yeah, this is also a divergent sequence. You are getting my point? What is limit? What is convergent mean? If a sequence has limit, it means that it is converging to that limit, and in that case, we will say the sequence is convergent.
Yes.
Okay. Okay, so I will give you an example. What is the limit of this sequence? Whether this limit is exists or not? See, when n goes to larger and larger, your ln,
Zero, sir?
ln, yes, 0. ln 1 plus n will go to infinity, will go towards infinity. And since denominator is going towards infinity and numerator is fixed, it means that the whole thing will go to 0 only. Right?
Yes, sir.
Right? This whole thing will go to 0 only. So in this case, the limit of this sequence will become 0. Okay. Okay. So here are some formulas or some special thing that I will rules. Here are some rules. Please check it out. If according to these rules, you will be able to solve the functions. Sorry. Okay. These all the rules. You just study it. If an and bn are two sequence, then and an is converging to this a and bn is converging to this b. an is converging to this. Sorry. If an is converging to this a, bn is converging to this b here, then an plus bn converging to a plus b, that kind of thing here. If an converging to a, c belongs to r, then c into an is converging to c. So this all the formula, just go through it. Okay. Okay, one more thing, sandwich principle. Sandwich principle. That I have already explained, I guess. Right?
Yes, sir.
What is it? Suppose this is a road which is like this, and you are standing here. You have only two ways. Either you can go by this manner, you can go by this manner. So if you will go towards infinity, it means that you will go towards this. So after some times, you will meet at the end of this, like in the limit of this. Okay, that kind of thing is happening. This thing I have already explained in yesterday's thing, right? Right?
Yes.
Okay. So for that, I am stopping the session. If you have some doubt, please ask. I hope this session will be helpful for you. Now, I will continue this session by tomorrow. Either the link will be new or this link will be continue. Okay.
Okay,
Okay,
sir.
sir. So I had a
Okay,
doubt with like a polynomial uh, function.
Okay,
Like
just
we are
ask what.
given like three polynomial functions. One that is with power x to the power 7 plus ax plus by sorry bx to no, b1x it will whatever yeah, yeah, yeah. It can be any power. The second polynomial is x to the power 5 plus ax plus bx cube whatever, and then a third polynomial that is x cube plus ax plus bx. So here this is not the exact question. I just like kind of recollected from my memory. Now we were asked if qx like these were pq and s. The first one is P, the second one is Q, and the third one is S.
Okay.
So if Q divides P, now like what will be the degree of the remainder?
Okay.
Now I think like within the first polynomial equation, sir, if you give me like 10 seconds, I can just go and refer the exact question and come. Is that
Yeah. Just go.
okay, sir.
Okay, others, if you have, if you don't have any doubts, you can leave. Okay. Good night, guys.
Good night, sir.
Nice,
Good
sir.
night, sir.
Good
Thank you,
night,
sir.
sir.
Sir, can we say a sequence as a subsequence as well? Yeah, you can say sequence is also a subsequence of itself, because you have to take that increasing order only, right? Nice observation, Siva. Very good.
sir.
Yes.
Sir, can I ask doubt from week 10?
Week 10. Okay. That particular doubt, right? Okay. Okay. I am writing here my, this is my
I
email.
know, sir.
Please message me here. Okay. I will give you the solution.
Okay, sir.
So just hold on. I'm opening it. So you didn't have your dinner, right?
No, I have.
You had? Okay, good. Because I was thinking you were taking this very long session. Sir, I have the question.
Actually, I'm
It's
in hostel, so yeah, you
Yes, sir.
just paste on chat box. Take a screenshot
Oh,
and paste
I
on chat
can't
box.
paste it like that, sir, because this is I have to send therefore maybe a link to the PDF. Can I do that?
You can take screenshot, right?
Yeah, I can take a screenshot, but then to share, am I allowed to share a photo?
Yeah, you can allow. So many people are sharing that photos.
Okay, then I'll do it.
You are allowed. You can do that. So
Okay,
basically,
sir.
I'm in IIT Madras itself right now. So I am living in a hostel. So I have to manage dinner according to them only. I don't have
Okay.
rights to go
So they're
wherever
like
I
this
have.
mess timings, I think, right?
Yeah, there is mess time. So that's this. So if the session is starting from 8, I have to go by 7 as well. Because the mess is
Okay,
starting from 7 and end up by 9:30. So
okay,
if I am in the session, I don't have any time to get my dinner. Because up
Okay.
to
So you will
12,
plan it accordingly where you can have it prior to the session, right?
yeah, exactly.
Okay, let me photo.
This session was longer than yesterday's.
Yes, sir.
It
But
was around 4
the
hours.
effort that you're taking and the patience and all that you're showing, it's we as students are very honored to have teachers like you.
Thank you so much.
Sir, I have sent it. Is it visible on the chat?
Right now, no. Vishnu Kumar, right?
No, sir.
No,
My name is Hari.
Hari.
Yeah,
Yeah,
yes, sir.
Hari, got it. Okay,
So
the
in
first
this,
question, right?
yeah,
Okay. So what is this? Look, I will just share this.
are you pasting
Okay.
it to the?
I think it is
Yeah.
visible to you as well.
Wait, sir. I was in the chat now. Yeah.
Yes,
Now it's
sir,
visible. Yeah.
visible.
Visible, right? Okay.
So here, sir, what I know is that when you have like a p of x, q of x situation and we divide p of x by q of x, there's a general rule that the maximum possible degree the remainder can have is 1 less than the degree of the quotient.
Yes.
Right? But in this specific case, given we are given like these exponents x to the power 5, x to the power 4 and all, and there is in the first p of x there is another what do you call it, like a monomial term with x to the power 4 in it. When we divide with q of x, some of these terms go away, like x to the power 5 goes away, x to the power 4 goes away, and
That's true. Yes.
so my point is, in these sort of situations we need to sort of divide and check as well, right? We can't just like say, oh, we can't just use that general rule here, right?
That we can use, right? Why we can't use? See, you have what is the question is asking? Firstly, let's see what the question is asking. Which of the following options is are true? This is your question, right?
Yes, sir.
So if R1 is obtained a remainder when QX divides QX, then the maximum possible degree of R1X is 2. See, here you are dividing by x raised to the power 4.
Yeah.
But the highest degree of quotient is x raised to the power 4. Okay.
Yeah.
So if I will give you some example like this, if you have polynomial like this x to the power 4 x square and you are dividing it x raised to the power 5, okay?
Yeah.
You are dividing this. So according to you, what will be the highest degree of quotient?
It will be like 1. degree will be 1.
Why? If for dividing this, you need x here. So
Yeah.
what you will get? X raised to the power 5 plus
Yeah.
x to the power cube minus minus, you will get x cube, right?
Yeah.
So
Now
this
we
will be
can't
your
proceed
highest
ahead.
degree.
Yeah, for the
now
remainder.
you cannot divide. So this will be your remainder. What is your highest degree?
Yeah, it is 1 less than the quotient. But what if there was a situation where x to the power 4 we are multiplying?
In this case, if you will take a1 and
No, if we
b1
had
and
x to the
c1 is
power
equal to
4, like right next to x to the power 5, we had x to the power 4 as well. Then what happens is that we can have another quotient like x plus 1 it will be, and we'll
okay,
kind of
whatever it is. Okay, just listen to me carefully.
Yes.
Whatever it is, doesn't matter. But here, just look at that. A1, AB1 and C1. There is no restriction on that coefficient, right?
Yeah.
They can be 0.
Yes.
If you will put A1, B1, C1 as 0 and A2, B2, C2 as 0, what you will get? You will get a situation like this only.
Yes.
Then, or forget about this A2 is 0. Just put A2 as 1. You will get a situation like this. Okay, then you will get reminder as x raised to the power 3. And then what will be your degree? 3. That is your highest degree.
One less than the
exact
device. Yeah.
Because here these are arbitrary. You can take any value, whatever you want. So see, you have a rule that the degree of the remainder should be 1 less than the degree of quotient, right? 3.
Yes.
Now you need to confirm this is the maximum degree of this or not. So just put some of the values of this A1, B1, C1 and A2, B2, C2 and try to check whether you are getting this degree or not in remainder. If you are getting this degree, then this will be your maximum degree. If you are not getting, it means that there will be some degree like rather than A1, AB1, C1, if they will give some fixed value of this A1, B1, C1, then you can say, yeah, what will be the maximum, what will be the degree of remainder. But here it is asking maximum value. It means that for a particular value of this A1, B1, C1, A2, B2, C2, if you are getting this degree 3, then this will become your degree, right? Or particular value you cannot get.
Yeah, that was my doubt, because generally, like what happens is we are saying the maximum possible degree for a general case is like 3, like in this case. But given it is a maximum possible degree, there could have been a chance where we could have had a power 2, degree 2 thing as a
There is
reminder
a
as
chance,
well.
but he is asking for maximum degree, and he did not mention that particular what is A1, B1, C1. It means that these guys are arbitrary. It means that whatever I want, I can put. So if I will put according to this manner, so I am getting degree 3, right?
Yes, sir, but there might be cases where I can eliminate the A2, for instance, by multiplying by B, like 1 by A2. Like for instance, we're dividing P of x, Q of x. So to eliminate A1 x to the power 4, if I multiply Q of x with
but make sure but make sure that your A1, A2 will not equal to be 0. But here A1, A2 can be 0.
Yeah.
They are not mentioning that kind of thing here. From where this A1, A2, A1, B1, C1 is coming. So you cannot directly divide it.
Okay, and given they haven't given me these things, but like saying that A1, B1, C1, it can mean that there are 3 different things. Like I can't just substitute everything to be 0, because they're not saying that it's like
you cannot like that. But see, you have that restriction, right? You have that restriction that the degree of reminders maximum degree of reminders should be 1 less than quotient. Okay. So if he is asking for maximum degree, it means that if I am getting for some value of A1, B1, C1, the reminder degree is 3, it means that will become your maximum degree.
Yeah, correct.
So you need to
But
find
in a
out that
specific
particular
case,
value.
if in a specific case, for instance, x square came as the maximum possible degree, I have to say x square only. Now, like in this equation, maybe the equation was formed in such a way that I was able to eliminate till x square. So in which case the remainder
in that
turned
case
out
you
to be
will
x
say.
square.
Yeah,
So when
in
that
that
comes,
case,
I have to say, when they ask me what is the maximum possible remainder, I have to say x square only, right? In that situation, sir?
yeah, in that situation you have to do like that.
Mm-hmm.
So in this particular situation, I am saying like, so you have to analyze what is going on there.
Mm-hmm.
Okay.
Yes, sir. In both cases, right? Where there is a next situation where s of x needs to be divided with p of x as well. So there we can have like x square, our first quotient could be x square, in which case x to the power 7 would be eliminated. Then we'll have this x to the power 6 term and x to the power 5 term, x to the power 4 term. So then we can go for x, in which case we'll eliminate that x to the power 6 term, but we will still have the x to the power 5 term, x to the power x cube term, and then we can eliminate the x to the power, we can't go there, we can't go to x to the power 4 anymore.
Yes.
So in which case the last remainder which we got was, I think, x to the power, the remainder that we get is x to the power 4, which is not one, which is just one less than the quotient. Yeah, it works in this case as well. Yes, sir. Okay, so thank you for clearing it.
Okay. Okay.
Okay, sir. Thank you so much.
Okay. Good night, guys. Bye bye.
Thank you. Good night.
Good night, sir. Good night, sir. Thank you so much.
Thank you, sir.
Okay.